Yeah, I think it might be time to do a last call. It doesn't mean that the document necessarily is finished.
अभी कहाँ यहाँ पे लगे तो उसको ले जाओ यहाँ से.
Everybody.
Yeah, so so I think we should start a last call, and if there's no objections. Doesn't mean the document is ready. It just means that all of you need to have a close, have a close look at it and let us know if you think it's ready or not. Sometimes it seems that it's necessary for people to, really have a close look at it, and I need to have a close look myself as well. But yeah, we'll post a last call announcement on the list in a few days, and please read the document and let us know what you think. All right. Then we have the IGMP MLD proxy Yang model draft. No changes since November. I'm not sure exactly if the authors want to add anything to it or if they believe that they are ready. The document is ready. Any authors that wish to comment or but yeah, otherwise we'll check with the authors what they believe the situation is. Not sure whether it's ready for a last call yet, but we need to at least find out what the next step is for the draft. But also here, it's great if people can look at the draft and give comments on the list so that we can keep improving it. And then we have the IGMP MLD extension draft, which is a new draft and it's just adopted. I'll be presenting this later in this meeting. We also have a start packing draft that just got adopted. That will be updated next meeting. I can just say quickly, the idea with that is that you can send in a way multiple asserts in one single message instead of having one message per S-G. And then finally here, we're trying to move IGMP version 3 and MLD version 2 to internet standard. And we had a survey trying to reach out to anyone that has implemented these protocols or deployed them and try to get their inputs. But we only got 12 responses so far. So I really would like all of you that have implemented or deployed this to please have a look at this survey. Right now it's reopen until the end of this month. So yeah, great if you can fill in the survey. It only takes a few minutes. And if possible, also share it with others that you know have deployed multicast, implemented multicast. So we would like vendors, ISPs, enterprises, and anyone using multicast to respond to this. Maybe should we repeat this in MWG meeting as well? But yeah, please.
What's the plan?
Sorry?
So after this month, the survey will be closed and we're going to finally be done with this. What then would be the plan to progress the draft to internet standard after that?
Right. So basically there will be like an internet draft that has like the proposed new version, or initial proposal for the new version, and it basically addresses errata that we have, plus it might remove certain things in a document that we decide that hasn't been implemented widely enough, or also if there's interoperability issues to certain things, we can try to clarify things in a document. So the important thing is there shouldn't be any new requirements. Anyone that is compliant with the existing RFCs should be compliant with the new one as well. But we can take stuff out or clarify things. So the big discussion, I think, will be in the working group based on this survey and otherwise. What do we think are things that have issues or are not widely enough implemented, if anything? But once we have that draft and once the working group is happy and think this should be the internet standard, then that will go through the approval process as usual through ISG.
Did you have a comment, Greg? Orsky?
Wonder because it's a very important step for the protocols, and have we notified other SDOs, especially because some operators might not participate in IETF and PIM in particular, but they might participate in other SDOs, for example, broadband forum. And multicast as part of IPTV is one of the topics, as far as I know, in discussing broadband forum.
Yeah, that's a good point. So IETF has liaisons with different standardization organizations and so on, and we should try to find a way to reach out to them and see if they have any input.
Thank you.
Yeah. All right. Thanks. That's what I had for the working group status. Any more comments or questions before we start on the first presentation? All right. I think that's it. Yeah, so by the way, as long as we have pretty much one person at a time that wants to make a comment, I think it's fine to just do that like we just have done so far. If you have multiple people that feel like they need to respond, then we should try to do the queue management with a plus queue. But yeah, so far it's fine as long as we don't have lots of comments at the same time. All right. Shall we move to the first presentation, Mike?
Let's do. Is Dino on the line?
Yes, I'm here. Can you hear me?
Excellent. Yeah, we can hear you good.
Yeah.
Why don't I go ahead and stop sharing then, and then do you want to?
Yeah, I want to play a little video.
Okay. This is going to definitely tax WebEx. Let's see if I can hang in there.
The share button's grayed out. I think that's the share button.
Oh yeah, let me see, I can try to do it. Just move the ball to you. I tried, let's see.
Still looks gray to me.
Yeah, are you able to move it, Mike?
What ball are we moving? I'm sorry.
You know,
I see. Yeah, I got it.
Yeah.
That's better.
Okay, that worked. Yeah.
Let's see. Can you see
Yes.
that picture? Oh, okay, great. Okay. Okay, so I haven't given a presentation like this in IETF ever, but our good friend Bo Williamson passed away on January 19th. He battled glioblastoma since, as far as I can go back, I was involved with trying to help him with this situation as best we could as two engineers, knowing nothing about medicine, back in December 2018. You can hear me okay?
Perfect.
Oh, okay. So yeah, unfortunately, he passed away on Sunday, January 19th, and the funeral was held the weekend following that. I was fortunate enough to be able to make it to a beautiful funeral and celebration of his life. This presentation here is Steve Simla, one of his close colleagues, giving a presentation, ironically or poetically, at the Barcelona Cisco Live, which was the exact week after that. So I'd want to play a few excerpts. I'm going to try to keep it within 10 minutes, but I think this kind of captured Bo and who he was. He did participate in the IETF several times, and he was the guy with a huge personality that always came up to the mic and always made us understand as designers how to make people understand this complex technology and how to deploy it. And that was a void that he really fielded pretty well throughout his career. But anyways, let's give this a shot.
Shortly, but
can you hear that okay?
Interesting to know about Bo Williamson, who passed away sadly.
Can you hear that video?
It's choppy, but it's working.
Okay.
A week and a half, 2 weeks ago, his funeral was just this weekend in Texas. And I just want to tell you a little bit about this guy, because if you take nothing else away and you don't know anything about him, he should inspire you over the next few days to do more than you've already planned to do. And I'll tell you why that is. He inspired me and he taught me. He taught me a technology called IP Multicast. His Twitter handle was Mr. Multicast. And these two pictures of him from a while ago, and the last one I have of him is actually from Cisco Live San Diego about 3-4 years ago, alongside a lady called Monique Fadao, who used to do Bonnie's job back in the day. I thought it was highly relevant that she would be up here as well. I know that Bo would appreciate that fact too.
I'm just fast forwarding it so we can skip over dead spots.
I have here those 519 slides, and we won't be going through them, but those 519 slides were Bo's multicast tectorial that when I first met Bo, he delivered on his own for 8 hours at Networkers year on year on year. And his scores, which I will share with you a bit later on because we all care about scores, were stellar. And he used to get hundreds of people coming, and I used to be there, and eventually I actually was given the privilege of speaking with him, and I used to see the same faces in the room who had been there the year before and the year before that. And I'd say, what are you doing? You know this stuff, and some of them had actually deployed this. See Bo. We just want to hear Bo, and that was the power, that was the magnetism of speaking capabilities. And have experienced it to know what I'm talking about, but you still can, and I'll tell you how. This very old t-shirt I am wearing was actually, you can see how old it is and how many times I've washed it. I was reluctant to wear it. It means I'm going to wash it again. It was built by the people who built Multicast, and I'll share with you some pictures of some of those people. And Bo, as you can see his name right on there, was one of those people who were honored enough to have their name on this shirt. This was on the 10-year anniversary of when Cisco built PIM. This commemorated what happened, the people who made it happen. And I was lucky enough to be part of that story, and Bo taught me what I know today.
Okay, jumping to 701.
What Bo used to do, I actually picked up on this. I can't speak Texan, by the way. I speak the Queen's English or something like it. But what Bo used to do is teach people Texan. So I'm going to teach you all the Texan. And this could be useful this week, by the way.
I think we need to mute our mic. Somebody's coming through.
You know what? Let's say I need to like turn it up.
So, eat yet? Did you eat yet? And the answer to that question is squeak. Let's go eat. Okay? So, if you actually want to confuse a European later this week, I highly recommend that particular line. But in humor terms, Bo actually, he's the only person that I first met that made humor out of multicast. He had a couple of really, really good jokes about multicast, and I just loved these over time. Those of you who know about rendezvous points, These are multicast dating agencies where senders and receivers come together and have shortest path trees. It's not that funny, but it made me laugh at the time, and it still sticks with me now. The favorite, I think, was the S,G RP bit prune. Shannon said to me, you better talk about this, or was it Tim? I don't remember. The S,G RP bit prune is the way you can guarantee yourself a quiet evening at a cocktail party. If you want to talk to the person next to you and you think, nah, just engage them with the S,G RP bit prune for a second or two. If they don't walk away from you after that, try the fact that PIM is a finite state automata. That was his other great line. And I want to offer this up to all of you because this was a Bo Williamson invention, and he didn't put a patent on it, so you can all take it away. The geekometer. Who's heard about the geekometer before? I know some of you have. So let me explain the geekometer. If you see a slide with the geekometer and it's moving up towards the red, you know that there is a significantly geeky amount of content about to come your way. Now, what Bo said he had discovered is that when you do this kind of thing to people in a room like this, people start excreting geek endorphins. And the way you can tell that has happened is like this, guys. Turn around and look at the person next to you, okay? Those are the evidences of that's the evidence of what geek endorphins can do to you, or an overdose of them. I wanted to share just a few pictures of Bo, and I've got some from his professional life and some of him as a family man. There's a guy who's been really helpful in pulling this together, and I'm not going to skip this without mentioning his name, Dino Farinacci. Many of you will know of him. Many of you will know of him as the inventor of Lisp. Before he invented Lisp, he invented PIM. And Dino helped me pull these slides together and give me content. You can see two slides here of Bo with Dino, top left and top right. Top left, I think, is before. Oh, and right bottom too. Thanks, Eric. But top left and top right are interesting. These were in Dino's house about 15, 20 years ago. And I think the top left was the first. And then Dino started coding in the top right. And it looks to me like Dino's just thrown out one of his many infamous bugs there, which Bo has just spotted. In the middle, you see Bo with Chris Lonvik and Leslie, who used to look after the consulting team in the US. On the bottom there, there's a family picture, or there's a family member. The very young guy in the blue shirt is Bo's son, Chris, who works for Cisco these days. And that was taken at the Dallas IETF. Bo lived in, or just outside Dallas in Texas. And then on the left-hand side is a picture I actually took. And this was an interesting evening because I did quite a lot of work about 10 years ago on multicast VPN. That side, I'm looking this side, it's that side, yeah. A multicast VPN with some Scottish people. And these were broad Glasgow Scottish people who we fed beers to. And when both Texan and their Glaswegian came together over some beers, it was an interesting evening. Some quotes from some people. I'm not going to try and read through all of these. There's at least one or two of you in the room here. Jane Butler, who is actually the person who introduced me to Bo, gave me the job of learning his course so that I could teach it. So thank you, Jane, for that. Max is here, and Max says he hopes he can pick up some of Bo's skills in presenting. Dude, you have all of them, but take more. There's some really lovely quotes up here from many of Bo's contemporaries. The one I probably like the most is from Andrew Ben-Hassy, who says, he will be sorely missed in the global networking community. To use a geeky parlance, the LED on the switchboard got a little dimmer for all of us yesterday. And it's true, and it's lovely, and it's poetic. And over here, Dino's dialogue with Mark Woolward, who was a former customer of mine at Goldman Sachs. He was in New York last week. There were people talking about Bo in New York. Some family pictures for you. Bo was a pilot. He was more than a pilot. Bo built his own F-16 simulator in his garage. Bo taught GPS training. He taught Morse code. He was a ballroom dancer. He was a woodworker. And he did multicast better than just about anybody I ever met. This guy was multi-talented, and we've really lost somebody special. And the only picture I was never lucky enough to meet his wife and his son, but the only picture of his wife there is at the top, Charlene, his wife, in front of a plane. And he met Chuck Yeager, who was a hero of his father's. His father flew in the Second War in an American fighter plane over Europe. So finally, I just want to close with some words to you all about how you can take Bo's spirit and memory into this event this week. First of all, if you didn't know already, he is still captured for eternity on the fantastic Cisco Live 365 archive. There are recordings of his sessions from the last 3-4 years. He spoke as recently as 2017 at Cisco Live in Las Vegas. He was an accomplished speaker, a distinguished speaker. Is Denise Fishburne in the room? Don't think so. If those of you who know Denise Fishburne, is going to dedicate her upcoming session this week and her future multicast sessions at Cisco Live to Bo Williamson. She has the remaining multicast session in the Cisco Live agenda. And this over here is Bo's book, which is still, to my knowledge, one of the finest books written about multicast I've ever read. So what would Bo ask you all to do as a result of the memory that I'm hopefully passing on to you today? I think the three things more than anything else that were true to Bo's heart and that made him such a great speaker was make people laugh, entertain them, make them think, provoke them a little bit, and above all, make them learn. You all know that's what you're here to do, and I'm sure you're all going to do a great job. And don't forget the Geekometer. If anybody wants it and wants to take it on, it could be carried forward. It still lives. Above all else, what Bo would say to you all is deploy IP multicast, okay? Thanks very much indeed.
So with that, let's all lift our virtual wine glasses or champagne glasses and wish Bo to rest in peace. Here, here, Bo.
Here, Bo. Thank you, Dino.
Yeah, that went really, really well. Thank you very much.
No worries.
I'm raising my Monster Energy drink right now. Yeah, he definitely had a larger than life personality and was very inspiring, particularly to me. So thank you. That was good. And that may have been an IETF first, and it worked really well. So
Yeah. Oh, great.
and your face is looking great. You're looking good today.
I'll mute now. Back to you guys.
Okay, great. Thank you.
Yeah, thanks a lot.
So Stig, you get to follow that. So can I give myself the ball back? Can you just stop sharing?
Yeah.
Just stop sharing. I'm trying to grab the ball, but it's not working.
I think I stopped sharing.
By the way, I realized we are not recording, are we? We should probably record.
I did hit record kind of like 5 minutes into it, so we're good.
Okay, great.
But I'm still grayed out.
Yeah, it would be nice to get that recording and send it to Chris and Charlene. They would probably appreciate that.
Are you able to grab the ball, Stig?
Let's see, I can try here. Okay, now I just made myself epicenter, but let me move it to you. Let's see. I only see one PIM working group here now. Okay, I'll share my slides for this one.
Yeah.
Let's see. I think it's this one. Yeah, does that look okay? Yeah, I think it probably does. All right, so I'll talk about this PIM IGMP MLD, sorry, IGMP MLD extension draft. So this is something we presented in IETF 106. And there was interest in doing this. The basic idea is that they want to have some way of putting additional information into IGMP version 3 or MLD version 2 messages. I'm doing this mainly because of some beer extension that you would like to have, but it can also be used for any other data that you would like to add. So this draft was just adopted, and yeah, people were generally in favor. Hitachi had some suggestions that I will discuss on my later slide here. But yeah, I should add, so the first version of the draft did actually include this beer extension, but I have since then moved this to a beer-specific draft. So the current draft is just talking about the generic extension.
I don't recall right now, but I can send you offline or either to the list to tell you what would be the plans about the software to be used here.
Thank you. Yeah, the list would be great. I often have to search to find things, so that would be even better than my own inbox. Thank you.
You're welcome.
Thanks again. Okay, we're going to move along. We need to push it a bit. Is your name pronounced Tathagata? Is that how, am I saying that correctly? You may be on mute.
Hear me?
Yeah, now I can. Very good.
Yeah, it's Tathagata. I mean, it's a little difficult.
No, it's a great name. So yeah, so go ahead. I'm going to share slides. Thank you. This is Tathagata's first IETF and first presentation. So let's
yeah, bear with me in case, yeah. So in case it's something that has already been discussed, because it's a kind of a thing that while we were working on, multicast came as a problem to us, and we wanted to discuss whether this is a problem that people have seen, and do we really want to fix it, or we keep it implementation specific. Next slide, please. I just have 1 or 2 slides, so I will not take a lot of time. So while we were trying to look into the PIM SM RFC, I couldn't see much on MTU specifications. So we thought, can we actually have something path MTU specific in the PIM SM RFC? I looked back into the IPv6 path MTU RFC, which clearly says that there has to be path MTU has to work for both IPv4 for unicast as well as multicast traffic. And for multicast, it should, based upon the list of outgoing interfaces, it should actually use the lowest one and respond back to the sender. But I don't see something pulled back into the PIM SM RFC. So I had some doubt on that, like what really happens. And I then looked into the IPv4 path MTU RFC. It doesn't talk about multicast at all. So it seems to me that something is little missing. Is it intentionally kept implementation specific to really handle that, or we can really improve the protocol in a way to handle situations where path MTU, where the MTU exceeds of the egress interface, and we can take some action on top of that. Because the reason PIM itself is like a data-driven protocol, like we program the multicast routes based on data itself. So is there a way we can really enhance based on the size of the data that we need to forward on the egress interface? Can we change something in the protocol itself so that the MTU part is considered? Because a lot of issues we see where the MTUs are not properly set, especially for multicast being used for IPTVs or video streams, and where the MTU size could actually go high. Next slide, please. So currently we see that we talk about path MTU only for sending of register packets and register stop packets for obvious reasons, because if they're IPv6 register packets, because those are unicast packets, it says that the sender should actually compute MTU and send the packet path MTU and do that to avoid fragmentation of the intermediate routers. What we are trying to propose is there a way that inside the PIM protocol we can say that before computing the outgoing interface list and programming that the mroute entry, we compute the MTU, and if the MTU is less, we send it whatever the RFC 80, RFC 8201 says, similar like that. But in again, if can we add some extension to the protocol itself, like if I am an RP and I have no source registered, I mean, say no users registered as outgoing, no joins have been received, so I don't do anything there. So the MTU path MTU stops. But if there are actually SG joins and I am transitioning from say a software routing to a hardware routing state, and I compute the outgoing interfaces, and I figure out that I actually cannot really program based on the packet size, I send an error and stay in that particular state. And then the DR keeps on that doing the same thing that it does for unicast path MTU. And the same implementation that typically is used for a unicast path MTU is extended for multicast. And we find the exact MTU from the path from the source till the host, and we get the optimal MTU so that we never have packet drops or fragmentations on the, because fragmentation itself, reassembly is a pain and cannot, then typically is not, doesn't work at line rates, and for IPv6 intermediate router fragmentations are also not allowed. So it's good to have that path MTU support inside the protocol itself. We have given some more details in the draft itself, but I would request for more comments and more comments or more suggestions, or if it is something that can be solved without extending the protocol itself, can also be discussed. Next slide, please.
I'm sorry. What I guess I'm not familiar with the hardware root, software root.
So what I'm trying to say is, hello.
Sorry, can I ask who spoke there, please? Who asked the question, just for the notes?
Jim Stevens.
Thank you.
So it's not inside the protocol. What I'm trying to say is, while you are in that connection establishment phase and you're not programming the entry in the mroute table, I just mentioned it as a hardware route and software route. It's not something the protocol itself talks. So I will probably correct it. It's something there in the slide itself. So before you are programming the mroute entry, where you program the SG, the OList entry for SG, I'm saying where you're still in the connection establishment phase, where you are trying to create your SPT and what you need to program into the hardware or whatever. I mean, not even say if you're not programming into the hardware or you're programming into the RIB. So at the transition phase, you compute the outgoing interfaces MTU, and if you cannot program those particular outgoing interface, you don't take that into consideration. So that was we have given some a little bit details in the actual draft that we have published there. Does that answer your question, or?
Let's just keep going.
Yeah, this is Stig. Just a couple of quick comments. One is, yeah, for IPv6, according to the RFC you mentioned, you're actually doing path MTU discovery also from multicast. So this works. This actually works today together with PIM. I'm not sure if all vendors support path MTU discovery from multicast though, but at least it's supposed to be always done for IPv6. And the way that is done is, yeah. But yeah, the way it's done is basically all just relying on sending an ICMP, you know, packet to big message if the outgoing interface is too big. So you'll basically get like a 3 MTU kind of, which will vary based on, you know, maybe if some new receiver joins, the MTU might go down and so on. So one issue I can see is in some cases, one receiver with a very small MTU might cause problems for all the other receivers. So there might be cases where you maybe don't want to honor the MTU. Another thing I just want to mention quickly is you might want to check also RFC 6807, which is pop count extension to PIM. So that has this mechanism where a PIM join can include an MTU. And by doing that, it's possible for the source of the tree to know the MTU even before there is data being sent.
Okay. So can you tell me the RFC? I just missed that last 6.
Yeah, 6807. I can put it in the chat here too.
Sure. So yeah, maybe, so that's what I'm saying. So maybe the problem is solved. When I looked into the RFC itself, I could not get a solution. It's which, so I'll go with 6807 and see if that solves whatever I wanted to do, or we still can have some enhancements.
Right.
Okay. Thank you.
Thank you. Appreciate it. That was very...
Is it still possible to comment, or was the line?
Go ahead.
No, very quickly. I think we've been regurgitating this for 20 years. My conclusion has always been, unless there is really strong evidence, we need to make sure that all the multicast applications actually run with a minimum MTU 1280 in IPv6, and that's basically what I got into RFC 3542, the extended socket API. And I think that's what pretty much, you know, all the applications are doing today. I'm not aware of any use of larger MTU or path MTU discovery. So before I think doing more work, it would be good to, you know, see more evidence of urgent need.
Sure. So are you saying that we don't see any multicast applications that would typically use higher MTUs?
I don't think anybody would want to delve into making it work better, given the overhead it causes, right? You've got 1 million receivers, and as Stig was pointing out, the 1,000,001st receiver gives you an MTU of 512. What do you do now?
All right, very good. Tathagata does have a draft that he's submitted, so let's read it and comment further. Thank you again.
Yeah, thank you.
It would be great to get some discussion on the mailing list as well.
Okay, very quickly, here's something on the order of bug fixing instead of coming up with something new. Next slide. Okay, so this actually happened to me in ISG review of one of my other drafts, where I was using IPv6 link local multicast for discovery protocol, the discovery protocol to kill all other discovery protocols or so. But in the end, the draft states that you must use MLDV2 to signal the membership, as I think it is correct, and as I think that's what we want as the working group. And then we had the AD comment that this is not common practice, which unfortunately may be true as well. And this is where we're getting closer to the problem, because when I was trying to find the proof that what I was stating is correct, then basically I ran across the following. Next slide. So, yeah, as I said, you know, every 2 years I'm asking the working group, and they're saying, yeah, of course, we do want in IPv6 MLD to be used also for link local addresses, because we kind of missed out of that in IPv4. And it has proven to be really bad with the amount of IPv6 link local multicast, especially when you got bridges over to wireless LAN segments. You really would like to be able to filter all the stuff that you don't need with snooping, and you can't do that if you don't have the MLD membership reports. And in general, there's really no reason to treat them differently. It was just, you know, a really bad historic leftover in IPv4. So when we actually wrote that into MLDV1, there is this sentence here that says that they are used for scope 2, Then unfortunately, when we went to RFC 3810, there is really no text at all where to use MLD on which scoped addresses. At least I couldn't find any. And the way I theorized about how that happened is that MLDV2 was written not by amending and improving 2710, but by actually copying IGMPv3 3376 and then changing all the address lengths to 128 bits, so to speak. That basically meant that improvements over IGMP that we made in MLDV1, like this sentence, were lost. So where does this leave us today? Next slide. So to the best of my understanding from that IESG review is that applications that are using MLD for link local multicast, of course, can, in my opinion, should explicitly state that they mandate the use of MLD, like in my ACP draft, because there's nothing in 3810 that states that this cannot be done or should not be done, because there just is no text about that, right? So, and it's really, from my interpretation right now, fully up to the application when to use MLDV2, which of course is bad, right? I think we, as the PIM working group, would want applications to be mandated to use MLDV2 on all the groups, link local or not. So now the question is, what can we do to further progress this? I've opened an errata, and that's where I'm kind of, at the end of my process understanding. I'm not sure what, if the errata is good enough, if we as the PIM working group need to kind of approve it or so. So I hope that Alvaro can chime in, or somebody knowledgeable with the process that, I should know about. And if not errata, then what? And that's it. Thank you.
Appreciate it. We probably should have known better, but we're going to go over the 2 hours here, just as a warning.
I think I saw a question from Alvaro.
Please.
Yeah, so since you, Alvaro Retana, routing AD. The errata is supposed to be used to correct errors. Omissions are not errors, especially if we're talking about normative language that would be added, as in you should or you must do this. So I haven't seen the errata that you filed, but I'm going to say that if it's not an error, I don't think we should do it through an errata.
Okay.
So that's it. That's the question that you had about the process.
So then we would need to do an update.
Then it would need to
So
be done some other way.
One comment on that too, though. I see that, MLD version 2 is just updating MLD version 1. So given that it's an update, doesn't that mean that everything that is in MLD version 1 is still valid unless it's replaced by something else? Doesn't that mean that it actually applies to MLD version 2, even though it's not in the text?
So you mean because it formally updates? You mean there's an updates tag somewhere? That's what you mean?
Yeah.
No. So apparently no one actually knows what updates officially means.
Sorry.
Yeah, I know. There is a draft in the Gen Dispatch working group that so in the ISG we have been discussing this for a long time because it is not exactly clear. It has never been defined. The only place that it was defined was in the RFC editor's style guide, which just says you should put an update tag somewhere. But there's no official meaning. So some people take it to mean what you just said. Other people take it to mean that maybe MLDV2 was just an enhancement to MLDV1. Others take it to mean that it was maybe a replacement. Others just say, oh, look at that other thing as well. So there's this draft in Gen Dispatch that tries to say, well, we should get rid of those tags and put something that is more specific, that is clearer. Tag, and I forget the names of the tags exactly, that say this draft actually updates that other one or it enhances the other one. or you should just go look at the other one. So no, not necessarily. And I would have to, again, go read MLD v2 to see exactly what it says. But I'm going with the assumption that V1 or V2 is superseded by V3 and V2 superseded V1. But that's just my assumption right now.
Right, but it also has the sentence updates it, but it obviously doesn't refer to anything in 2701. It defines the compatibility with it. So it's really complete rewrite like IGMP v3 was as well.
Right. So I would imagine that no, that the answer to your question, Stig, is no.
So, but then what would be the, what would you recommend? A one, 2-pager update for 3810?
Assuming 3810 is MLDV3, is that what that is? Or
it's MLDV2.
Well, whatever. So yes, if you want to change a behavior of something, yes, you need to go do an update. Whether in this case it's a 1-sentence update or review the whole thing, that's up to the working group to decide what the best way to do that is. If nothing else is going to change. Now in this case, I think what you're saying is that for link local IPv6, you must use MLD, right?
Well, actually, there is no statement that you must use MLD for any other group either, right?
There is no statement right now, but that's the statement that you want to add, true?
Right, exactly, yeah.
Yes. So the other thing that I'm going to ask you is that to coordinate with the 6-man working group.
Okay.
Right, the last thing we want is for us to say something that IPv6 must do without IPv6 knowing that they must do that.
Yeah, but it's basically, as I explained, also going back to some of the alleviation of link local multicast issues, right?
Still, we need to coordinate.
Oh, of course, completely, yeah. It should be fine with 6-man, but you're completely right. Should be brought to the attention. So maybe we'll just start a small 3810 bis, and maybe we'll jump over one or the other by letting it run for 1 or 2 years. Okay.
Yeah, don't call it bis unless you're going to revise the whole thing.
Oh. Okay. So what?
Yeah. If you're only going to add a sentence,
right.
It's just a 1-sentence update. Right?
Okay. Then it's 3810 fix.
Whatever. Sure.
Okay. Thanks.
Jake, did you have a quick question?
Yeah, I just want to mention that if this is a known problem that many implementers have sort of failed to consider, then capturing that in the sort of operational considerations or I could recommend adding this to the 1-sentence draft that you would.
Oh, definitely, yeah.
Yeah, thank you.
That thing will not be finished very quickly. Everybody will jump in and.
Indeed. Hopefully. It would be good to know where this is happening, because yeah, thanks.
Well, it has to be officially PIM that owns the Magma documents now, I think, like those IGP documents, but then 6-man, of course, has to cross-review it and approve.
Thank you.
Great, thank you, Torlis. Human, I've got your slides. If you could not go over the technical details and just kind of give us an update of where the draft stands, that would be just the first couple slides, that'd be great.
Sure. Just a second, Warren, did you have a question too, or?
In the chat room, I was just agreeing with Alvaro that nobody knows what updates means, and it's a fun discussion. That was all.
Okay, sure. Yeah. Okay. Thanks. Yeah.
The floor is yours, Human.
All right. Perfect. So next slide, please. So obviously, we are all under this lockdown here in Canada, and I was a little bit born beside putting a picture up with the snow on my lawn, or my kid pulling my hair out. I decided to go with the later. That's my personal update. But from the draft point of view, so there is a replication segment draft that is in the Spring Working Group. And as of now, as you guys know, there are some challenges in the Spring Working Group. There's a single chair. The queues are full with other requests, including the SRv6. And even though in the last IETF we had overwhelming support for the replication segment draft, the email has not gone out just because the single chair is completely overbooked and he was not able to send out that email. But again, I'm going to repeat the fact that there was overwhelming support for the replication segment in the spring working group. And we did do a adaptation call on the PIM group with regard to the point-to-multipoint policy. And there was overwhelming support with regard to that too in the PIM group. With regard to the implementation, given the fact that the drafts are a little bit behind because of situations out of our power, there are multiple vendors that are going ahead and implementing these drafts and the other relative drafts, which if you can go to the next slide, please. So these are the other drafts that have been all put into the IETF, and the vendors are implementing most of these drafts. Now, with regard to the other drafts, I already explained the situation for the Spring replication segment draft. With regard to the other draft, like the point-to-multipoint policy for the PCE and the IDR, which is the point-to-multipoint SR TE policy, if you will. Implementation is still on the go. There is agreement between the vendors that are implementing these drafts, but they're all getting stopped based on the Spring replication segment. As soon as that guy goes forward, then we can we're gonna have a flurry of I guess drafts that are going to be adopted and start being implemented on. Now, since you don't want me to go through the technical stuff, which is fair enough, I guess the last part, one thing that I wanted to bring into the table here is the replication segment is a small portion of the point-to-multipoint policy draft, meaning that the point-to-multipoint policy draft is really the architectural draft and is the draft that explains this idea inside out. Meanwhile, the replication segment, given that it has the forwarding information of the multicast state, this is why we decided to put that draft and that a small part of it into the screen. So one question here, I guess, to the working group is, given the current situation with the spring, would it make sense for PIM working group to pick up the torch and to lead this effort forward? So then all these other drafts, including the PCE and IDR, could start, we could start having conversations on them. That's all I wanted to say from update point of view. So I guess the floor is yours with regard to my question. I don't know whether that makes sense or not.
I'm going to put your face back up there because this is my favorite slide so far. But yeah, so that, Alvaro, I'm going to ask you to chime in here again, because I know that we've shared a little bit different opinions on this. I'm kind of more leaning towards just, yeah, let's accept it and see what happens. But it does have reliance upon the draft that's in spring, this replication segment draft. So what we agreed between the chairs of spring and PIM is that the spring chairs just said, yeah, go ahead. You guys could feel free to adopt it if you wish. But the consensus among the chairs and the AD was that, let's just wait on that draft to be adopted in spring before we adopt it, your draft in PIM. Although I know your name's on both of those drafts. But so it may be, in this case, better to have the working group get some feedback, because right now it's just kind of been between chairs and Alvaro, do you have any comments further on whether or not PIM should be adopting?
Sure, I have exactly the same comments that I told you before when we talked with the spring chairs, which were, and I was just frantically looking for my email because I obviously don't remember everything I say. But what I said, I think, was that I would prefer us to delay the adoption until spring adopts. The reason for that is that, as far as I understand, there is a dependency with the draft here in PIM on the draft over there. There's nothing that precludes the working group from working on the PIM draft, even if not adopted. So that's my opinion. This is your working group. You do whatever you want.
Sure. Maybe, are there any comments? I don't see any in the chat. So maybe we'll
I'm mistyping it. I'm trying to get to the queue, but I'm missing it and go to the one. No, I think I would support what Alvaro was saying and maybe return in the same way that Alvaro is saying that we need to inform 6men on stuff. So basically, if this goes to spring, then they should basically, update us, whenever, there is some affection to what PIM working group should know.
Sure. Who's the remaining spring chair?
Bruno's a spring chair.
Okay, because he's the one that we've been talking to.
Yes, correct. So, yeah, so just that everyone knows, since I think the last, not the, whatever, IETF 106, maybe even before, the topic had come up, and so Mike and Stig had already been in touch with Bruno. And Martin, the AD for spring, was in, as well on, what do we do? Are you adopting this or not? Or, where do we move to? So, yeah, so that's what we had talked about. Now, I just want to say one more thing. The same way that nothing precludes the working group from working on a document that hasn't been adopted. In fact, it would be great if people actually reviewed documents at all stages of the lifetime, the life of the document. Adoption, during adoption, after adoption, before last call, all that stuff. There's nothing that that forces the working group to publish anything that has been adopted. Right? So, there are some working groups that adopt work not based on the draft, but based on the work. And so what that means is that what the result could be is something completely different. Again, that assumes active participation and active review of everything. So again, it's up to you. Just there's an understanding that there's a something else that needs to happen before anything changing the name of the draft.
Right. And I'm gonna mute you again, Turles, because you're banging pretty good there. So yeah, okay, thank you. We need to move on. Thank you, Human, but I think we just need to, as Alvaro suggested, just continue to work on your draft. We've already had a adoption call, and we, as a working group, have agreed to adopt it. I think for now we should, maybe we should take it to list and get people's opinions. That may be the best thing to do, and we'll do that actually. But for now, we'll just assume that once things do progress in spring, then we're just going to quickly officially adopt it and just continue working on it. That sound clear? Okay. Okay.
Thank you.
Okay, good. So we have one more presentation. Lenny and Greg, we apologize for taking longer than we expected.
We'll take it out of your flesh later.
Yeah. So I'm trying to think of what we should do here. So we've got one. It's a good presentation. It's an operator presentation. It kind of fits in both our working groups. Would you prefer that we have it be shortened and then so you can go on to yours, or do you want to just, just let's all assume that we can hang on this call for another hour, or what's your preference here?
I'm okay to keep going. Operators, I'd never want to cut off an operator, so let's go.
Yeah, okay.
How does everyone else on the phone feel, the phone D participants feel about staying a little longer to get through our agenda? Just someone. What was that?
That was one fine.
So this is Warren. I unfortunately have to drop off, but if Alvaro is staying around, he can do whatever he's doing.
All right, let's get rolling then.
Okay, thanks. right. I think I'm pronouncing it correct. Guyan? Guyan? You there? If not, this may be really
unmuted. I just unmuted.
Okay.
Can you hear me?
Okay.
Looks like I had a double mute. Sorry about that.
All right, so we're just gonna let you go through your slides, but if you can, you have a lot of slides here. If you can maybe just highlight it, that would be
Highlight it. Sure.
perfect.
Sure.
Thanks.
We'll do. So Stig had sent out a survey about regarding like IGMP v3, MLD v2 implementation. So I responded back to that survey, and then I had mentioned like Verizon's worldwide SSM deployment. So I think when Mike sent out the agenda for the interim, I had responded for adding to the agenda. So I thought it was a good, useful use case for operators, I guess, with large SSM deployments. So with that, move on. Next slide. So Verizon, we've had an ASM, I guess, architecture for many years, and we've always thought of, kind of looking at SSM as a way to kind of simplify our architecture. So just kind of give an overview of our architecture. So we have a typically we've used SSM, we use multicast for enterprise wide webcasts, and the enterprise extends worldwide. So we do have over 100,000 some employees that watch webcasts. So with the way the architecture works is we would have, let's say, we could have a remote presenter that could be like anywhere in the world, and they would actually send a stream, and it would be a unicast stream that would be sent from anywhere in the world, and it would come down to a broadcast center domestically within the U.S., and then from there we would send it to. We use a product called RAMP, which we've used, and I have another slide on that, but really the main key of that product for multicast is that we wanted a product that actually is able to use a browser for webcasts and not actually have a separate application on the endpoint like a Windows or Mac or whatnot endpoint. So if folks are familiar, there's a application API, Netscape, and it's called NP API, so Netscape Netscape plugin application programming interface. So most of the newer browsers today, like Chrome, Firefox, and Safari, and some of the really more common ones, they don't support that. So the real challenging part was trying to find a browser that we didn't want to have to load an application on an endpoint. So RAMP has a product, and I'll go into that like a little more detail, kind of how it worked, and it all supports SSM, which was nice. So we were able to, procure this product, and so that's kind of really on our endpoints. So we have this stream that comes in, so anywhere in the world you'd have a presenter. It would get backhauled down to domestic, then that would actually get audio video filtered and then shipped over the stream. It would be an HLS, so an HTTP live streaming stream that would actually get shipped over to a source server, and then that server would source the multicast out, enterprise wide, so worldwide. So that's kind of basically the overall architecture with the deployment. Go ahead, next slide. So SSM, the nice thing was with the product with RAMP, it did support, and even with SSM, we didn't have any issues with Wi-Fi. I know Wi-Fi in general with multicast is, it's kind of prone to issues, and it's really just based on like connection speeds, and I think there are some RFCs related to that when you try to connect over multicast, it drops to like the lowest speed, and then you always have drop packets and connectivity issues. And we use the product, Aruba is the vendor that we use for our Wi-Fi deployment, and they've got a feature that when the SSM stream comes in, it would unicast that with like an optimization down to all the endpoints. So it would be an incoming SSM, and then it would replicate that out to all the associated Wi-Fi users. So that was kind of a nice success. So we had throughout, we had both LAN and WAN, and any LAN, wired clients, and then Wi-Fi clients able to view a worldwide webcast. So anywhere in the world, at a corporate office, they were able to view the webcast. Next slide. So the ramp product, kind of how it works, since this kind of plays into some of the SSM, and kind of the feature that we did look at was with SSM. I guess a nice feature is you can have like an HA type of concept, like active standby, where you have two. With the SSM subscribe channel, when you subscribe, you can have the same multiple sources for the same group. So we had an HA group, so you could have an active with multiple backups, or a round robin style, where you're actually sharing a group. So that was really nice to take advantage of that with SSM. So with the ramp product, what it would do is we would actually have a source stream. It would be it would be a HLS stream that would be encapsulated. So we'd have an incoming HLS stream that would come from a source encoder, and then it would be encapsulated into a UDP wrapper, and then encrypted, sent across a multicast distribution tree. And then any endpoint receiver would actually have this agent running, which we call a ramp multicast plus receiver agent. It would just take that, it would take the packet, the payload, unencapsulate remove the wrapper, and then it would play it out on the local loopback, and then you could bring it up on any browser. So it was really nice to actually not have to have extra software. You just have this agent running, and now you can actually play it out on any of the common browsers. So that was really nice. Next slide. So there were some challenges with Verizon in deploying multicast video with SSM, and I think probably one of the biggest ones was related to SSM IGMPv3 support. I mean, it seems like we've gone so many years, and IGMPv3 has been around for so long, but there's still vendors out there that just don't support it, or have issues, or whatnot. But having a workaround to get IGMPv3 to work, or getting SSM to work where IGMP is not supported on the host, that was kind of the big challenge. So overall, let's say, I have some applications listed on the source side. We had a Windows server that was okay. We had a Wowza Media server that did some of the encoding, and then we had encoders and decoder appliances, Haivision, and that was no problem. They all supported it. And then of course Ramp, the product for the endpoint and the source, that all supported it. And then the receiver OSs that supported it, like Mac, Microsoft Windows 10 and 7. I think Windows has been supporting, I believe since Vista, so that was nice. Apple, Mac, that's all supported in the versions over the last few years, no issues. And then most of the Linux versions, we didn't have issues as well. Where we did run into issues, and I actually said in the slide, I kind of had a mistype. Where it says receiver OSs that do, it should have been do not. So we had issues with the Mino. So there were set-top boxes that we had. It's around the world where we have basically a set-top box appliance that's connected to a plasma screen, so it would get an SSM stream that would come in, or a multicast stream, and then it would hit the last hop router, and the Amino set-top box would be sitting next, connected to the plasma, and it would actually do a static join. So that join, there was issues with that join actually supporting, even though the vendor said it supported V3. We just couldn't get it to work after trying, so many different syntaxes to try to specify like a source, for the join. So, and then we had Citrix VDI desktops that didn't support it, Chromebooks, Lansquin. There was other miscellaneous, but it was enough that, it definitely made it difficult, if you want to deploy SSM, but all your endpoints got to support IGMPv3. So that was definitely challenging. At the bottom there, there's a few options we had. So there was IGMPv3 Lite, MLD Lite for host signaling, URD, which does the TCP intercept to decode a source comma group, S comma G, to build the channel. And then there's the SSM map, which I think out of anything, that was kind of the nice one that we ended up going with to support. Go ahead to the next slide.
Questions at the end or the slide?
Yeah. So next slide. So on this slide, what I just kind of shared. So I guess the way with the SSM map, I guess how that worked. It was kind of nice that if the host not supporting SSM, what would happen is this host would still send an IGMPv2 report, but then what would happen is then on the last hop router with the SSM map, he would actually inject the source into the report, and then a channel join would be sent by the last hop router upstream. So like R1 to R4, you'd actually have, or R3 to R2 with the other sources on top, just as examples. It would actually send an and S-G join, which is nice, and then the stream would start. So that was really, I would say, the biggest thing that really helped us in deploying SSM. I just go on to the next slide. So overall, I think with Verizon, with the use cases, as far as ASM and SSM considerations and comparisons, I would say with ASM, I think what we found, definitely the complexity, we really, tremendous complexity with the MSDP meshing and peering and whatnot for inter-domain routing, and then the RP, having to have all the ACLs and whatnot, SA filters, and what. So that complexity kind of is completely eliminated with SSM. So that was really nice. And then I think also with ASM, the controls are built in. It's all network-based control because you have network-based application, network-based source discovery, whereas SSM has application-based source discovery. So all that control mechanism built into ASM is all done on the network. So you have a million ACLs. So you have a lot more complexity due to those ACLs. Where there's always a trade-off. With a double-edged sword with that. With SSM having application-based source discovery, it's all built into the application. But now you don't. Of course, there are some cons of not having the network-based source discovery. But the nice thing is all your controls are there, so it eliminates ACLs and whatnot that you have to, manage and administer on the network with SSM. So overall, that really, it really simplified the architecture, just going completely SSM, end to end. Go ahead, next slide. So this is kind of like an idea of like ASM, with the MSDP meshing, just to kind of show like this is like a typical region where we have had ASM, and all of that elimination was really, really nice to completely eliminate all the MSDP peering. So that was really a big, huge plus and a gain with SSM. Go ahead, next slide. So just so we have webcasts that we have almost daily, and they're like to our Verizon employees. So it's kind of nice to say kind of a big success, with SSM. So 139,400 employees, worldwide, whether you're on a wired LAN or Wi-Fi, you're getting that multicast feed via SSM. So that was a big win for us, and I guess overall, for SSM, a nice big worldwide deployment. I have the last two slides, and they're just kind of more questions and comments for the IETF, just food for thought, and I think we can just scroll down to those. So these were, just go down to the last two slides. Actually, go up two more. Yeah, right here. Yeah, right here. So this was something that actually came up when we were deploying. With ASM, you have the domain concept and you have the RP concept. So, with SSM, I guess the actual RP context completely goes away. So now you have just one big SSM domain. So, in our use case, we didn't have it, but there may be other operators that may have use cases where you have different administrative domains, or for whatever reason you want to like break up your big domain or your tree, but segment it. So the only ideas that I could think of, like, probably outside of like really at the SSM, at the multicast layer, but maybe, at the provider layer, maybe if you're doing inter-AS, because of course, if you have a, large network, you may be going through providers, multiple service providers or multiple, enterprise providers. So doing an inter-AS to segment it, or I guess if you're doing if you're running SR, either SRMPLS or SRv6, using SRT to segment it. Outside of that, I couldn't think of any other real way. It's not a use case that we have today, but it's something that was thought of, and it's something for MBON and maybe the PIM work group to think about, if that use case ever came up and somebody was migrating from ASM and you got all these domains with the RP context, now everything is just one tree, but you still want to have some kind of like administrative segmentation. That doesn't really exist. I think once you're with SSM, now it's really one tree that builds all the way through. And those are the two ideas that I had thought of. Go on to the next slide, and this is the final slide here. So this is another thought I had, and just kind of working with SSM and after our deployment, just kind of food for thought. So with SSM, I guess you don't have network-based source discovery, and ASM does, and just kind of the pros and cons. SSM definitely has a lot to gain, with the simplicity, which is really nice. So an idea I had was, maybe using like SAFI2, multicast, or an LRI, you know, to actually do, let's say if you had sources and they were geographically dispersed, but the challenge with application-based source discovery is if you've got, you know, if you have hundreds of applications, let's say if you have many applications, not even hundreds, but many applications, but then they're all, and you have all these disparate sources that are from, you know, they're spread everywhere. Is there any easy way, you know, and if let's say, you know, the application-based source discovery really being not as scalable if you have a large number of sources, how could you actually, you know, make SSM provide for network-based source discovery? So this is one idea I had. The only caveat is I think I did some like basic, you know, like proof of concept and then as an idea, and I think it would work. I think in general, the SAFI2 I'd mentioned, it's used for incongruent technologies, you know, where you're incongruent unicast and multicast with ASM, where, you know, where MSDP for PRPF check, but using it for SSM, it would just be to basically, you know, advertise all sources, so all the receivers get all, the last hop router gets all the sources, and then you could actually map the sources to groups. So just an idea. And then I guess last is, I guess, questions or comments. That's all I had, Mike.
Awesome. Thanks. I think Turles had a question.
Yeah, thank you. So you listed the compatibilities on the receiver side, which obviously is very interesting to us. I'm very surprised and, you know, somewhat doubting that, for example, Chrome OS shouldn't support IGMPv3. Is it possible that this is just, you know, missing support for SSM in the receiver application, or could you elaborate on what you try to determine that the OS really doesn't do IGMPv3?
So you know what, I think the Chromebooks, I think it was really, you know, what it's been some time since I've tested, but I think the Chromebooks, they did not support multicast, not just ASM, it was ASM or SSM, it was just unicast. But it's been a little bit of time, so I think it was really, so it was not really kind of from an ASM. I think once it supports ASM, it would support SSM, and I should have probably mentioned that, but it didn't support multicast, and I think that was something that was down the road, but it was on the roadmap, but it didn't support it.
What are the receiver applications you're using there?
So the receivers, I would say primarily, I would say mostly it was Windows and Mac. So Windows 7.
Application, I mean, what application?
So the application, they were really just web pages, so homegrown applications. It would just basically you'd hit a web portal, and the portal would have whatever group. So the source information was off the portal, like the channel lineup would be on. So it'd be homegrown. So we'd have our own application that would be like a head-end page that you would hit, and that would have the group, whatever groups, I guess the channel lineup of groups.
Are you saying that the streaming is from embedded in the browser in JavaScript, or?
So it is, yeah. So the streaming is embedded in so it's not in a JavaScript. What happens is, so the product that we were using is called RAMP. So for most of the hosts that we had, so what would happen is the source, there would be a redirect. So you'd hit, let's say, a landing page, and then that would redirect you to a URL for the source, and that source the S, G would be in that application. So that would actually be sent down to the host, and then the host would actually do that join. But it would be on the when the redirect happened to the stream. To whatever stream, so let's say whatever stream you were going to hit, it would actually be a redirect, and then that redirect would be to that RAMP source server, and then that would actually send that would give you the S, G, the channel, so that you subscribe, and then you would do that subscribe to that source.
Right, but on the receiver, something is running, right? It's either
yes. So on the receiver, there is an agent, and it's what the agent is doing is it's actually sending a join out, and then because I think I talked about it earlier on a slide, but when the stream, let's say the native content is, let's say, an HLS, which we use in HTTP live streaming, it would be and packaged in a UDP payload. So it would be sent UDP multicast through the distribution tree down to the receiver. The receiver would unpackage the UDP, and then it would actually play. So before that, actually, I did miss a step. So there's an agent running on the receiver. He would send out the join. So he would have to send the join out to NIC, so that channel join. The join would be sent out. when the stream comes through, the stream would come through, and it would hit the NIC, and then from there it would unencapsulate the UDP, and then it would play it out on the loopback, and it would play it out the player.
Excellent.
Yeah.
So how long has this been stable? What you've been explaining here, all this stuff?
Sorry, I didn't catch that, Charles.
Last question, just how long has this been stable in terms of what you're saying has been running for how many months or years?
It's been years. It's been I guess almost 3 years.
3 years. Okay, cool. Thank you.
Yeah. So I think it was a very good success with SSM, and I think overall, I mean, it's been pretty solid. I think for MTTR and like mean time to recovery and complexity and not having to deal with like shortest path switchover, that I think that's always been kind of a nightmare. You have a shared tree, but now you don't have your S, G, and you're not building your tree. That's always been a nightmare to troubleshoot. Trying to figure out why that shortest path switchover is not happening. So it's nice just the tree just builds. As long as you're not having an RPF check failure, or like PIM is not missing anywhere along the path. And there's no ACLs to deal with. Everything is just kind of flows, and all your control mechanisms are built into the application, because the application is providing that channel to join. So that was really nice. I would say for sure that really made SSM a huge win for Verizon.
You had a question, Lenny?
Less a question and more just kind of you asked maybe an answer. So the two questions you brought up at the end again. If you could bring up the slides, the last two slides, where you talked about the interdomain.
Yeah, interdomain. It was just some ideas that came up, because I think when you're like think about ASM and then you think about SSM, and then of course you like compare and contrast them all, and then thinking about the domain construct, and that's but it's an interesting topic, I think. That's why I threw it in.
What I would say to that is that the domain, it really just because there's no RPs doesn't mean there aren't domains.
That's true. That's true.
So you can, if you abstract, there is one slight difference, and that is you can control the SAs going from one domain to another and one RP to another. So you do have policy there, but in essence, if the SA MSDP SA made it from, I think you had a picture. Yeah, go one before this.
Yeah, one before this one. Yeah, there you go.
Yeah. So imagine an SA goes from domain A to domain E. This multicast source, when he joins and he sends his star G to the RP in domain E, the RP in domain E will generate a source specific an S, G. So in essence, domains B, C, D, and A all disappear and look like one domain. So because it's an S, G, and in that sense, it's really SSM is really no different. So I would say it's almost no different. And you can think of, because I would say the top picture is it's a domain nominally, but in essence it really isn't. And then so you could just as easily transplant that second thing and just say SSM domain A, SSM domain B, SSM domain just C, D, and E. There's just no RPs, and you can use PIM policy. You can use PIM policy and scoping to create any kind of domain, borders and boundaries like you did before.
With multicast boundaries, and that there are some cases where we had to do that multicast boundaries. So I think, as you said, you still have that S, G, like even with the ASM, when you switch over to that shared tree, the shortest path tree, it looks just like SSM. You got that shortest path tree. So, as you said, it's still the same. Right. So it was just an idea that came up, but I don't think like anybody would. If you had to, as you said, I think doing that multicast boundaries, I guess, if you had to do some controls, I guess that's how you would do it.
Yeah, you've still got PIM policy and multicast scoping, so you can do it in the control plane and the data plane. But in your next slide, you mentioned, what about carrying source in something in the network?
Yeah, go to the next slide. Sorry.
Yeah. So one option there is, first off, BGP is so in one less.
One more. There it is. So no, go one. Yeah, that's it. That's it right there.
Yeah. So
actually, it's the one after that. Sorry, it's a multi-protocol. I think the SAFI2. There you go.
Yeah. So instead of doing SAFI2 and MBGP can do this, and in fact, it's doing it in MVPNs, BGP MVPN with Type 5. routes. And if you look, so the BESS working group just adopted a basically BGP MCAST and or multicast BGP or BGP multicast, what it's called. But essentially that you're carrying all the multicast state, you know, the source, the group, and I'm pretty sure it also carries the SA information as well.
I think it does. I think with the MVPN, I think because you have like the types, I think for like AS, that's true. So, you know, I was just actually trying to draw an analogy, like but I think with MPLS or SR, I guess you have the MVPN procedures like that are the 6513, 6514. So you would actually do like the I think it was like type 4, yeah, type 5 and type 4, I believe is like MS is the source is the
yeah, the type 5 routes.
Right.
Basically
Yeah,
are
type
doing what
5,
the
right.
MSDPSAs were doing.
Right, MSDPSA, right, the active, source active, right, the MSDPSA.
And the new draft, the new draft for BGP MCAST is basically carries that information in one of the.
As well, right, yep. I'm aware of that, yeah, the BGP multicast draft, yep. So that would actually be a good one, I think, for this, so that would kind of be like the solution to for the network-based source discovery, agreed.
Jake?
Yeah, thank you for bringing this. I'm interested in following up offline because in my presentation that we clearly should drop, but I'm going to keep doing anyway. For the MBOND, first MBOND slot, I have a call for participation at the end, and based on what you described here, it sounds like you might be an interesting candidate. So I looked for contact information in your slides. I didn't see any. Can you either reach out to me, I'm jholland@akamai, or paste your contact at akamai.com, or paste your contact in the chat, perhaps, so I can.
Yeah, sure, I can do that.
Follow up offline. Thank you.
Yes, we'll do.
Okay, thanks. That was a fantastic presentation, and it's MBOND time. So let's get comfortable and do it. So who do I pass the ball to?
Well, some would say if you could pass it to me, Mike, because I got all the slides teed up, and some would say MBOND started early because our charter's deployment reports.
Yeah,
so
there you go. Perfect.
We'll claim that one as our own, maybe.
Sounds good. Yeah, thanks.
So I guess we'll use the same ground rules that we're using with PIM, which is add plus and minus your name in the chat window, and that will put you in the queue. And I would say please sign the blue sheets if you haven't already. And if somebody could paste the blue sheet thing. Last I looked, there was about 27 or 28 signed names in the blue sheet, and there was like 39 participants. So there may be a few people missing. All right, so bringing up the slide here.
We're continuing to use the PIM notes for MBOND.
Yes, and FEMI has graciously agreed to continue with the notes. We're going to use the same, we're just going to squat on the PIM Etherpad to make life easier. And then when we post our notes, we'll just cut it. Okay, let me see if this is coming up.
Just to say, regarding the notes, I've tried to capture what everybody has said, so please review it, and if I've misrepresented you, just edit it away and correct it. Thanks.
Okay. Can you guys see my?
Yes.
All right, cool. All right. Here's the note well. We're still under the PIM note well, but it's our it's the same note well if you so just keep in mind all the things and note this well. All right, so here's our agenda. Quick status of working group items. Jake has 3 drafts under the collective multicast of the browser umbrella. And I'll give kind of an update on the multicast to the grandma deployment architecture that I presented, I think it was in 105 or 104. Anybody else have anything to add? I'm going to bash the agenda. Okay. All right. So status of the currently active working group items. Jake's Dryad draft is in auth 48. Keep an eye out. That is imminently about to become RFC, I believe 8777, something like that. So an early congrats to Jake on that. The deprecate ASM draft, which Gian, it might be worth checking out. It's because it kind of covers a lot of some of the topics that you talked about. It's currently in the RFC editor queue, so that should be published very shortly.
Okay.
The multicast problems draft. So that one's still awaiting some revisions. Mike, did you have some updates on where we're sitting with that one?
Right, yeah, so we've been kind of going back and forth between authors and the IESG to take care of some issues. And then recently, as of last week, there was something that you may have seen that Linus Lucing brought up on the list with regards to issues with MLD and Android power saving and sleep mode, and shared some solutions he thought may be doable. And so I invited Linus to join us today. He was not able to make it, but so the long and the short of it is that we still have a fair amount of work to do still yet, but it's going to happen to get it.
You have an ETA when you think you might get the next? Are you rev away, or is there still conversation?
One big rev away. We have a bunch of transport type issues that the transport area gave us to do. And it's a little bit overwhelming, but we just got to get it done because we put so much effort into it. And then new issues like what I just mentioned from Linus keep popping up, and we're like, okay, fine, we'll include it. But eventually, we just got to get it done and publish it. But it seems to be a worthwhile document.
Cool. And then there's the deploy draft, which went working group last call, didn't get enough support. We did a second working group last call, only got one or two more comments. One of them was pretty comprehensive from Jake with some pretty substantive comments there. Mike?
Yeah, so
what do you think?
Yeah, so that one, you know what? If Femi and I need, who are the authors in the draft, need to let it go, we'll let it go if it's not worthwhile to the working group. We thought it would be, but if there's not really interest in sending it off to the ISG, then fine. It's a draft, it's recorded, and we'll use it as you can use that as a reference. But we'll just take the working groups.
Yeah. So here's what I would say. I read, I was one of the commenters. I think there's value. I think it's, within charter. And the folks who have responded and reviewed the draft seem to say similar things, that there is value here. There just hasn't been enough. So kind of a message to the working group. It's a short draft. It's an easy read. Take a look and comment if you think that this is of value and we should advance it. If you don't think it's of value, then say so as well. But we'd love to have more comments and thoughts and people to share and provide feedback on this one. Greg, did you have any other thoughts on this one, on this deploy draft?
Oh, I'm game. I like this. Thanks, Lenny.
Okay. All right. So I guess here's the question, Mike, because Jake had a lot of substantive comments. Would you want to rev the draft based on Jake's comments, or because it doesn't make sense for you to rev it and then find nobody's interested, or do we want to do one last, chance at it and see who all is interested?
Yeah, that's exactly my thinking. If we don't want to put the effort in, if it's not going to be.
Gotcha. All right, so
yeah,
we'll take one last swing at this.
Yeah.
And if there's enough comments that'll motivate you to, rev it again, based on the feedback. Otherwise, we will let it fade into the night.
Sounds good.
And there's the Yang models draft. That is Sandy on? We haven't heard much update in a while on this draft.
There's a couple of questions from Jake and Warren, by the way.
I wanted to reiterate, I think I said in my review that I do think there is value in that draft, and I think it's pretty good. I just, yeah, so I don't mean to derail it if my comments are there. I just wanted to mention that and encourage the authors. Yeah, I see where you're coming from, but I kind of wish we could get more comments too. Yeah, thank you.
Great. Okay. All right, Sandy. Is Sandy on? All right. No word from Sandy. Okay, other drafts. These are the three. So the other active drafts are Jake's 3 drafts, and he's going to cover these now. So actually, I see Warren.
Yeah, I guess Warren Kamari for the record. I was just thinking, while we have everyone on the call, do we maybe want to get some people to commit to reviewing the DC deployed draft? You know, and if people put their names forward now, then we can get them to actually review it and provide feedback.
That's a great idea. So, do we have any volunteers? And for some reason, I cannot see the comments or the chat because I am sharing. So I don't know what's going on.
34 names in the room. I'm sure at least 10 people, 5 people could put their names forward.
So I'm only assuming that a bunch of people, since I can't see the chat window, but there's a bunch of people raising their hands in the chat window saying, I would like to review this and comment. Is that the case? All right. Anybody else? Any other takers? It's a nice short draft. You too can be a contributor.
Dino said he reviewed privately. Ship put his hand up.
Okay.
Come on, folk. Make me come down there.
Let's see how it goes. All right, moving along then. Maybe it might be easier to have Jake, do you want to drive the slides or shall I?
If you could, that would be better for me. I don't want my notifications popping in. I haven't taken steps to avoid leaking things that I should not leak.
Okay, fair enough. And I am going to try to do that. But I don't know. For some reason, WebEx is not letting me do anything now. Change what I'm sharing. All my buttons are not doing anything.
I did prepare to present, so if it is substantially easier, I don't want to hold things up. And I think the only main danger is if notifications pop up with anything sensitive, but hopefully it won't be an issue when I'm in present mode.
What do you see right now?
I just see your viewing Lenny's application. I think you're sharing a PowerPoint and not the PDF, if that's.
Yeah, unfortunately, I can't seem to.
I don't see anything.
Push to change what I'm sharing.
It doesn't say anything. I don't see any content, but I do see it saying viewing Lenny's application.
Yeah. So Lenny, which app are you using? Are you using the web app or in the WebEx meetings? Web app?
Yes.
Oh, shit, I'm not certain where it is there. There's got to be some mechanism somewhere that pops that stuff up and lets you make changes.
I do see the button, and I'm trying to share.
If you're using the web app, you need to grant your browser exit. Okay.
All right, how about now?
There it is. We got it.
Perfect.
All right, good. I found it.
Great, thank you. I will try to keep this shorter than my initial. I was worried I wouldn't be able to fill 30 minutes. Haha.
We hope you don't.
Yeah, no, I'm trying not to. Okay.
Realize your fears.
So I guess the one thing I want to say up front before I lose people I have a call to participate at the end. I'm looking particularly for carrier partners to ingest traffic according to the architecture outlined here. We want to validate the architecture and make sure that we get something that's really going to work. And we are in talks with a number of people. And so anybody who is interested, please just jump to the last slide, send me an email, and we can hook up offline. But I will go through a quick update of the slides. A quick update of how things stand for the benefit of anybody who can stick around. Yeah, so next slide, please. So as you know, the drafts are adopted. I'm not going to do a detailed presentation about the techniques. There's a link there if you need to review it or you'd like to watch it. But just as a quick reminder, there's three main things: dorms, AMBI, and CBAC. And what they do is the metadata is in dorms. That's the substrate that provides the metadata. AMBI is the one that provides the data integrity, and CBAC is the one that provides hooks for bandwidth management. And I have just lost a view of your slides.
Better?
Yeah, that's adequate. Yeah, go on. Next slide, please. So I got a great set of offlift reviews on all three drafts from Dino. There were a lot of comments on AMBI with several rounds of back and forth. There were some substantial comments on CBAC and some brief comments on dorms. I'll go over a little bit of what my TBDs are on these in light of having gotten these comments so far. Obviously, still interested in more feedback from other people, and a big thank you to Dino. Yeah, next slide, please. That is the word count, by the way. So 15,000 include. This is basically just a text dump of the email threads. But 1,500 lines and 15,000 words with Dino and me. It was good times. I encourage getting a Dino review anytime you can. All right, next slide, please. Yeah, so for dorms, the comments were pretty straightforward. I have several TBDs that are still in there. One I didn't list was I still need to add the IANA section. Yeah, lost you again there. I have my local one if others.
Sorry.
Yeah. Technical difficulties are always fascinating in these unprecedented times, as they like to say. Do we have the slides back, or okay, there we go. Something's coming. Great, thank you. Yeah, so there's just a few minor clarity enhancements and a clarification about the metadata that's provided. My incoming assumption with dorms is you already know the SG out of band. There's not a network-based discovery of the SG. So this is coming from apps, from app logic of some sort that is going to be learning about the SG. And that is out of scope for this document. And that the other main thing to capture is that the primary value the dorms provides with the metadata, in light of the app being able to gain anything it wants, assuming it can gain access to the SG, the primary value comes from providing that metadata to other management domains that are not otherwise privy to the app level data. So I thought those were useful suggestions, and I'll be fleshing that out. I have not updated any of the docs yet. This was just like 6 weeks ago, which feels like a longer time by now. Yeah, next slide. I'm hearing somebody talking. I don't know if we can mute them. Anyway, so from CBAC, there were some major clarifications that suggested, and I see where he's coming from about the how confusing some of it was. Among the issues was the terminology of ingress and egress collides with a lot of kind of data forwarding concepts. And so the circuit breaker terminology might not be the right way to use the overall, because there's like overlap with concepts of forwarding in a multicast network, a multicast capable network. And so I'm going to be looking at a different way to explain it that tries to not collide with the circuit breaker terminology so heavily, and to explain more in context of a sort of CBAC-centric way of looking at it, with just a section that sort of ties that terminology together and points out exactly how it maps to the circuit breaker concepts. So that's going to be probably a fairly significant text overhaul, I think. I'll be aiming to get that done as some of the other work goes forward and proves that it'll actually be worthwhile. And also an operational consideration section, I think, is another really good suggestion to add, and to be sure to cover the concept of what to do when there's multiple CBAC circuit breakers in the same network, and possibilities for some optimizations that they could perform that are out of scope of the document, but to point the way to some useful deployment models. There are also several TBDs that are still in the actual text talking about things that I just intend to add. Again, I have not updated the document itself yet, and so those are still pending TBDs. But these are the things I know about. And yeah, next slide, please. So for AMBI, the reason we had a lot of discussion was this is the third person who's tried to tell me that what I'm doing is too complicated, and this is a a troubling trend. Unfortunately, none of the people who tried to tell me this have been able to suggest something else that does the same job yet. So I'm open to finding another way to do this that is less complicated, but it has to be something that works. And so as far as the doc goes, I'm obviously, if we do in fact find another way to do this that would be less complicated and a better fit, then I can, I will let the working group know and declare an intent to drop this draft and adopt the other approach instead. But for now, I'm still intending to go forward with the way that it's described in this draft, roughly. So, but in an effort to head off that discussion from the next 3 reviewers also, I'm hoping to add a section that talks about the designs that don't work, and to cover those in some detail to describe why I can't do it in some of the ways that might at first glance look like they might be simpler or more straightforward. I have a very sort of hand wavy and just based on a reference to a few other things at the front of it, but I can outline this in a little more detail and try to sort of capture the points that seem to have been points of confusion so far. And another thing that from some of the same people that consider it complicated and perhaps suspect that there's a simpler way, which I don't want to say they're wrong, because there might very well be a simpler way. But to highlight that the AMBI's use in the network is optional, and that even things where we intend to go forward with developing an implementation, like in the browser, then if there is another way to provide integrity, then AMBI is not necessary, even if there is a requirement within that context that integrity be provided. As long as the integrity is provided in some other way, that's also fine. One thing that might work is, for example, a generic UDP solution for Tesla. Now, some of the people that don't like AMBI also don't like Tesla, and so I'm not sure that will necessarily do the job. I like AMBI better, so I'm going to start with that one. but at some point I might end up writing the Tesla idea as well. And certainly I'll any developments along these lines, look for future updates to go there. But this is you know, very much sausage making kind of figuring out where we're going. But for now, the plan is still to go forward with an ambient implementation and to get that moving pending any better ideas. So what I'm hoping to do, but this also is the doc that I want to get furthest along. I think it's the most critical for getting things into the browser. And so what I would like to do is get my top priority in the doc work is to get this into shape for requesting a security review and make sure that it's in sort of a reasonable state for a first round heavy technical review. Yeah, next slide, please. So we have a question from Dino and maybe Lenny. I'm not sure if Lenny's plus Lenny means
first.
Yeah. So yeah. So my question, you sort of answered it, was, do we need this in order to get this in the browser? And is your answer you need something? And this
I think so.
If it's not this, we need something else, and it's not clear what the something else is.
Yeah, that's kind of my current understanding.
Okay, thanks.
Yeah, and Dino?
Well, I think there is a simple solution if you just say we use asymmetric keys. And what I mean was, if you just put a signature in the packet and have the source sign it with its private key, and its public key is put in dorms, then all receivers could verify each packet with the public key. However, we believe that there's no good asymmetric algorithms that are fast enough. If we can find them that are fast enough, would you think that's a better solution? Question.
Yes, that's a fair point. So if we had an adequate cipher suite and we were reasonably confident that we could do this at the right level of performance, then yes, I would have done. That was my first idea, in fact, and you know, my section about that so that is going to be one of the designs for sure that'll go in the rejected designs that don't work. And I'll explain how the reason it doesn't work is because of these benchmarks, and you know, point to something sane about that. And the only reason that doesn't work is because of the performance. Like if you try to run video that way, you can't do it, and that's, you know, not on today's hardware. Maybe one day we can do it.
Jake, do you think any of the security area guys are they working on any new state-of-the-art stuff to make that work better? Do you know? Because I know elliptic curve and Edwards curve is much faster than RSA, but obviously not fast enough, right?
Right. So that's not only that. So I'm going to say it doesn't matter because my timeline for getting this going is before that. So I am actually totally open to moving forward simultaneously, especially if somebody else wants to do the work, with another you know, another document that can do the simpler job, and that like you could very well define a new asymmetric signature approach where you inject a signature as a shim into a UDP packet, and you have sort of a generically authenticatable UDP payload that you can deliver in exactly the same way, doing exactly what you just said. I do agree that works if you go slow enough. My problem is it doesn't fit my use case because I want to do video, and you know, among other things, and nobody can sign it fast enough, and nobody can verify it fast enough. And so the only problem with that approach is that it doesn't work because of performance. So I do think that although I'm not going to use it, having that protocol in our back pocket for when a good algorithm, when a fast enough algorithm comes out, might be worthwhile for the future. And if you want to write that thing, then I will absolutely support adoption. But I am not going to write it today, and I might not get to it.
I have another quick question. If we can authenticate, if we can use an authentication mechanism that's different than the integrity check, would that work as well? Because if, like in my comments to you, I said, if we could sign a few set of bytes, like 16 bytes or even 8 bytes, that would be relatively faster to authenticate. But you want The way we have Ambi working now, you're doing both with one solution, right?
So that is actually the way that signatures usually work, but it has to be a one-way hash that's actually a crypto secure one-way hash that you sign, because otherwise you're not providing data integrity. So
what I'm saying is, could we, if we had a different mechanism to do integrity checking than authentication, you could make authentication go fast. Now, to make integrity go fast, unfortunately, you have to process every byte of the packet. Has to be part of either a checksum or you know what I mean, or yeah.
So in general, I would say read up on some security stuff, because my real requirement is it has to pass security reviews and it has to be actually solid, because there are 0 days in video players, and we cannot allow it. In my opinion, browsers, it's not safe to allow browsers to accept unauthenticated data, because there are easy injection paths in the network, and it's and I mean, that is my opinion, and also the opinion of every person I've talked to who checks code into the browser. So I really think that it has to be a serious and secure solution that provides integrity. So under those constraints, I am supportive of making a simpler thing, but I'm not going to do it. Okay. Anything else? And please, I would encourage discussion of this on the list, because I think getting more eyeballs on it might be helpful. Yeah. So if there's nothing else, then next slide. So I've implemented a very simple dorm server by taking JetConf and putting the right Yang models into it. I have it sort of, it's a work in progress. It's in the kind of infrastructure that becomes a thing that gets deployed, not just a like barely running on my laptop, but something with an eye toward getting it there. It's not something I can demo to you today, but it is something that is on its way to being something that you'll be able to access. And next slide. The browser work, we have started, a dev team has started working on it, so it's not just me hacking on the weekend anymore. It is, people who actually do it for real still. And they're doing a great job. I mean, it's amazing. They've got like tests and everything. It's awesome. And our internal goals before we engage externally are coming to a head imminently. Our internal proof of concept sort of criteria is to make sure it actually fits our use case, and we are going to. So we have an LMS product that's how we deliver stuff. It sounds actually quite similar to the RAMP product described before, and also quite similar to the new DVB spec that came out from the DVB group. But this is a deployed product, and our intent is to just leave a roughly unmodified server version of that, encoding data according to the way that we encode data, and to use the WebAssembly SDK that we're sticking into the browser, or sorry, to use the API that we're sticking into the browser in a WebAssembly SDK that can be delivered through a web page with the new proposed API that we're working on, and to actually make that play video using the browser's MSC APIs for playing video. And then the next steps after that are to lean in on getting our API upstreamed into Chromium to the best of our ability. So obviously this depends on many external factors, and we are doing our best to do a credible and worthwhile job. It will face some, with any new kind of API like this, there's always questions about like how important is this. Participation and comments about the W3C API, especially after we update it, because we have some updates we're going to be doing, will be I feel like will be helpful to getting the sort of credible forward progress on that that has some obvious external support. So I'll be maybe I don't know, on a monthly cadence or so, begging for people to chime in various forums if they are able to, and I would very much appreciate support there. It might make the difference between things moving forward or not. Yeah, that's it. Next slide, please. So there's a number of other next steps that are a part of turning this into a real browser extension. And we are using the libmcrx I presented once before as our base way to receive the multicast. We're going to be adding Ambi support and Windows support and probably a few other bells and whistles here and there. We'll be trying to put up a scalable Ambi sender of some sort. That's a relatively major undertaking and also a critical part of making sure that this is actually going to be viable in production. We have with a big thank you to Max for our hackathon project last time. We have a start at what that might look like, and some evidence that in terms of the signature scheme, it's something that is plausible at the data rates that we want, but it's going to be still a project to get that to get like the kind of fan out that lets you scale, because we're starting with unicast delivery of the manifests, and that is not something that you do all from the head end if you want it to scale. So and then obviously the doc updates for the W3C API as well as the 3 IETF drafts. And I am hopeful that at some point the multicast ingest platform that I've published and also talked about here before, that we would be adding Ambi authentication as a sort of ingest firewall checker to that if it turns out reasonable. But that's I'm not making any promises. I'm just saying it's on my radar and maybe we'll do it. Next slide, please. So for what I'm aiming for this year is making good progress on getting the browser API upstreaming underway, to actually get some stuff checked in that is, in the first stages, it's going to be like probably behind a command line argument to turn it on. So you can only run it like if you have the special build in Chrome and you call it with the right command line argument. But as that starts getting further along and sort of passes the various rounds of review, that it's a very tight, heavily reviewed ecosystem to get code into the browser, and that will be an ongoing thing that will depend on how well it turns out working. But we're making a serious effort at getting it in there, and I'll keep you updated on how it goes. And the other thing is that we want to validate the architecture, and this is another key part for staying committed on our end, is to get some good engagement with carriers and make sure that it's actually going to be something that will be possible to deliver, and that it kind of meets their needs for being able to ingest this traffic from external sources like ourselves. So we are currently looking for participants to work on these kinds of trials. There's several people we're talking to. Yeah, next slide, please. In some, we have several content owners that have already said yes and that are willing to work with us. We have several carriers that have not said no, but are also not like a clear we definitely want to do this. Like, it is more work for a carrier, but our goal here is within, like, I put 3 years. I think that would be optimistic. I think 5 years is maybe achievable, but we think that ultimately we want to deliver all of our most popular content this way. Anything that's being actually consumed concurrently. We have prototypes that can do file download as well as the linear video that we have that's actually released as a product already. We have plans for how we can turn the linear video into sort of 2-minute offset or 30-second offset carousel, so that things that are super popular, like within the first hour or two of it coming public, even though it's video on demand, we believe that we can deliver significant multicast offload by streaming those with multicast, and we believe that is implementable and something we can move forward with if we have the the sort of delivery infrastructure. So we're really only getting started with the linear video part, and when you take those considerations together, then our belief is that we can achieve 50% peak and 20% typical day-to-day reduction in our overall traffic output based on what we think is addressable from what we currently deliver today. And we also believe that that by doing this in an open standards process approach, that we can that this is available to others to use the same infrastructure as well. So it's not just our traffic, but also potentially other people's traffic. So we are looking for contacts with carriers, introductions to people that you think would be interested in this from carriers, and this is a very timely time to get started with this, because if we have reached out to 30 people and we get 30 no's within the next month, then there is a chance that we would put this on a shelf and come back to it some other time. So I just wanted to reach out to anybody that you can hook us up with that would be in on this. And that's the end. So yeah, Tarlis.
Yeah, thank you very much. Great progress. So I'm not quite sure, what you really like to do about AMBI, right? It's certainly, cryptographically a very interesting thing to do. But if you feel that this is also a possible roadblock for more adoption, then I think it would be good to better analyze under which circumstances AMBI is really necessary, right? And maybe that could be done by appropriate explanatory text in AMBI itself. The way I see it is that, AMBI is really only necessary if you have something like free content that you are able to stream to non-DRM encumbered receivers, right? As soon as you have DRM encumbered receivers, I think the whole picture already changes, because these receivers have to be trusted to comply with the DRM system, and all the existing broadcast systems are based on the fact that you can't basically extract the keying from such a DRM receiver, not only to decrypt on other places, but also not to be able to re-inject fake content using the same key. And I think for most of the commercial traffic, we unfortunately have to fear that the receivers will be DRM encumbered, but that should relax the requirement on something like AMBI and instead moves it into DRM.
Well, that is an interesting approach, and yeah, I'd be willing to explore that. Maybe I'm concerned that would not satisfy the kind of threat model that is. So if you consider RFC 3552, I think it is, in section 3, where it talks about the internet threat model, and the notion that we have obviously observed on-path attackers for video traffic in the past. Things like ad hijacking, where somebody who is in a position to actually just drop in actually different traffic is it's something that can be automated and that can be done at scale. And it's not just like ad theft is bad for the content owners and deliverers, but it's worse if there is sort of exploitation of 0 days during a popular event.
But there is nothing that has seen more money and viewers being used than broadcasted DRM traffic, right? So the whole premise of being able to lock down receivers to the extent that symmetric encryption keys cannot be extracted from them is, I think, something that has been proven the most on the planet. So that's actually the answer to exactly that threat model.
All right. It's an interesting proposal. I think it would require some significant changes to the proposed browser API.
But here's the question, right? I mean, in the first place, you're trying to authenticate, but you're still trying to keep the encryption, right? I mean, and you're assuming that probably some other system like the DRM is dealing with the encryption, right?
Yep.
So, I mean,
anything that's encrypted would have that going on, yes.
exactly. And the DRM would already be the piece. I think you're just, removing the requirement of MB when you're saying, I have a DRM system that is exactly one of these existing DRM systems, right? We can still argue about whatever other channel is there to authenticate a DRM receiver and give it the decryption key, but it's locked down. The key is
tell you what.
from it. Yeah.
All right, I'll tell you what, Tarlis. If you can find me someone who has ever checked code into the browser, who would be willing to make the argument that it would be okay to receive HTTP video segments and to authenticate them purely through DRM, then I will talk to that person.
Wait a second. Microsoft Silverlight with multicast support has been around for a decade now, right? And that's doing it.
Hey, Torlis, we are really pushed hard to dive into this
offline.
On the email list. And when I ask if you have text specifically, offer the text to discuss on the list.
Thank you.
Like almost, at 40 minutes over, and we still have one more item to get to. And now we're running other people's agendas. Thanks for your input. Please take it to the list. Anyone else have questions? You got more stuff to do here? Jake, you got more slides?
That's it.
Okay. So how do we take for, I want to make sure we get some traction on this, Jake. I want to see people pick this up and follow through in any way we can help as a working group, as a chair, as the IETF. Please let us know. If you want to do something on, specifically in the working group and track it that way, we can. Just want us to reach out to the people, operator communities and stuff. And I'm sure we can help you make connections if you don't already have them, but it's not a bad place to start here.
Sure. So I'll just mention that sometimes our connections they're through the CDN interface, folks, with the carrier, right? And that's not always the best place to reach the people who might be interested in deploying multicast. So my ask is really if you know of someone who would really be interested in deploying multicast in their network and who might be able to make it happen, it might be helpful to get an introduction and to just bounce it off them, whether they're in the loop on whatever conversations we might have been trying to have. Some of the carriers we've reached out to just kind of haven't got back to us, and it's not clear whether we just reached the wrong person because that's the context we had, or so hitting a different contact with an intro from someone like Shep or Torlis or Dino, who's famous enough here already, would maybe do the job, So thank you for that offer, and please do help me if you can, because we haven't closed the loop on that yet, and I would say there's a chance,
Have you reached out to any operators group, like even suggested presenting at NANOG or taking the NANOG list?
Well, things kind of got.
Yeah, I know.
No, we haven't got there, and I kind of wish we had, but that might be a next step if we can't. But
I'm sort of thinking about this. You and I have talked about this a lot, and we've been in a group for a long time, and we're always looking for those big targets. The truth is, you go to an operator group like NANOG, and the majority of the people there are from small operators still. They're still, willing to do stuff without, taking off the massive corporate risks that come with large organizations. So I think, reaching to various knowledge might be a great place to get some traction.
Yeah, if you could send me detailed suggestions on that, I would appreciate it. Thank you, Shep.
Will do. Thank you. All right.
Thanks.
Next.
So the last one of the day. And Greg, when I bring up my slides, I can't see the chat window, so just shout out if anybody has questions.
Okay, there was 11:35 question from Anime Working Group.
That was Torless.
He's done. All right, next. I mean, not done, Torless, you know, but done. All right, no more questions.
All right, so, okay, can you guys see my slide?
Yes.
Right here, multicast of the grandma.
Mm-hmm.
Okay.
Quite relevant today, actually.
Yeah, it is. It is. Yeah, so that's what I'm going to kind of talk about, how this stuff is more, you know, as relevant as ever in light of recent events. So I presented this a while ago, and I think it was in either Prague or Montreal. And this is just kind of an update. We've been making steady progress. So first off, what is multicast of the grandma? And that is, you know, multicast. It's so multicast over the internet that is ubiquitously available over for everyone, not just for the folks who are participants on this call. And it's also, you know, not just a hope for a distant future, but something that actually is working today. So I'm going to talk about what we have in place today, and hopefully see if other folks want to get involved. So first off, you know, I'm kind of preaching to the choir here, but why would we use multicast? And you know, there are still plenty of people who would say over the internet, video seems to be working just fine right now. Why do we need it? And if you just look at the bit rates, you know, the numbers start to skyrocket pretty quickly from HD to 4K to 8K to VR. And I stole this from Jake. At least the last time I heard, every year Akamai apparently breaks their traffic record. And the last time I saw it was 72 terabits. That was the most traffic over the internet. And if you just divide 72 terabits by 40 megs, you know, how many 4K streams would that be? And that would come to 1.8 simultaneous 4K viewers. That's all it would take is 1.8 million viewers of the same video, streaming video, to set a new traffic record. And to give you an idea, that would correlate to the 179th most popular TV show. Got 101.8 million viewers. So that's all it would take is if you took the 179th most popular show and streamed it all over, instead of over broadcast television, but over the internet at 4K, you would break the internet record.
So Lenny, I think we're up to 168 terabits per second is our current record, but I think the core insight still stands. It doesn't change really. Thank you.
Okay. I have to steal your latest slide, so.
I haven't made new slides, but go.
All right, and you know, so what we've been doing thus far is I would call it brute force unicast BFU, and can we keep up? So that was 1.8 million viewers. The average audience size of the television audience for an average NFL game, not the Super Bowl, not a playoff game, not Monday Night Football, but an average NFL game is 15 million viewers. 15 million at 40 megs at 4K, that would be 600 terabits. So that's an order of magnitude higher than that. And if you just look at the television audience for other main event, you know, the Super Bowl's, you know, typically over 1 million, over 100 million. Cricket is 200 to 300 million, and the World Cup of Soccer is about 500 million viewers. Also, in the last few years, I'd say the last 2 years or so, the cord cutting evolution, it kind of started with things like YouTube and Hulu and Netflix, and it was all about on demand. But recently, all the energy, it seems to be in live, and you're seeing kind of, this is like the last stage, I think, of the cord cutting evolution, is how do we get live? You know, when you talk to neighbors, they constantly say, well, what do you do about live television? You know, because there's sports, you know. Actually, before a month ago, there used to be sports on, and it was, and people used to watch. But if you see, you know, there's Hulu TV, YouTube TV, Sling TV. So live linear television is not dead yet. In fact, you know, live streaming is actually trending. And it's because we live in a fake world of fake news and deep fakes. And we're becoming a much, you know, lower trust society. And due to the kind of spontaneous, uneditable nature of live content, live streams are perceived as more authentic, and they drive greater emotional engagement. This is something that marketers have found. It's more effective. They get better return on the investment. I'll go through this quickly. And it's, actually live streaming is the fastest growing type of video online right now. Of course, recent events with the current pandemic is illustrating more the need for solutions that can enable people to gather virtually together, like working group meetings or distance learning, worship services, movie watch parties, happy hours, virtual happy hours, working group meetings, interim meetings, things like that. So we're seeing now that everything isn't just on demand. Live is still alive. So what's new? Internet multicast has been around since the 90s. It hasn't gained a whole lot of traction, and I'm talking about internet multicast. Regular multicast, I would say, has been fairly successful, but internet multicast is not ubiquitously deployed. Hasn't gained much traction. Well, why should we think it should be different now? And there are a few things that are different. First of all, ASM deprecation. And that's, the draft that we talked about that's about to become an RFC and a BCP. It's already been applied as the best common practice in Internet 2, which is the largest component of the MBone. And once you get rid of ASM and you move to SSM only, we eliminate about 90% of the complexity of multicast. All the stuff that people complain about multicast, it's too complicated, don't want to do it, the juice ain't worth the squeeze. Those arguments go out the window when you just deploy SSM only. When you do SSM only, you've got no RPs, no MSDP. Essentially, it looks an awful lot like LDP, and you don't hear people complain that LDP is too complex.
Hey, Shep's got his hand up.
Okay. You got to shout because I can't see. So what do you got?
Well, just to the point, having been one of the early cheerleaders for the beer movement, some of these, resistance came from the get-go. I hate multicast, I hate multicast, I hate multicast. You people, beat that drum. And it was clear early on that they don't hate multicast, they hate PIM. We should make that distinction in our discussions. Network replication has got incredible value. We've just been unable to deliver it with all the pieces we have so far. Now, I'm not saying jump this to a beer discussion, but that's the same point with SSM and ASM. It's not that you hate replication. It's that the solutions we have today are so complicated, they're bringing you things that aren't providing value, they're taking the value away. We're starting to remove those things and leaving you with the value prop that is the replication that you need, without all of the complexity. And the other issue, of course, is the insecurity that comes with ASM.
Right. And I would go further and say, you think you hate PIM, but what you really hate is PIM ASM. Yeah, you hate sparse mode. You hate rendezvous points. You hate MSDP. You hate all that stuff. PIM SSM is actually, the cooler, younger cousin of PIM sparse mode. And that's the guy you really like because he looks an awful lot like LDP.
So, and what you got me, ping me offline here, an email, because I did a presentation like this working with the BBC last year, and they've got tons of great new information about how they're losing bandwidth in terrestrial RF space. And they will not have enough RF bandwidth for their eventing soon enough. And there's not enough CDN space in the entire country, the UK, to handle even one live event. So, yeah, they're wedged.
So another development in recent development is overlay networking. With things like AMT and Lisp, we can address some of the fundamental all or nothing problems of multicast. When I started, I remember that tunnels were seen as a suboptimal hack to be avoided, and we need to go native because tunnels suck. All you have to do is just rename it to overlay networking, and it's cool now. So that's kind of a nice recent trend that we can ride on top of, and say, oh well, we're back to the future here with overlay networking.
And remember, beer is an overlay network as well.
Exactly. So all the pieces are in place for a working solution today, and that's the key thing. We have something today. I think Dino said it really well last month on the thread that got us here in this meeting. This isn't a technology problem. It's a lack of product problem, and we're working to try to fix that problem.
I'd say it's worse than that, because I've worked with a team where we put together a product, and there's those on the phone here that were involved. We showed that it worked. We were intent as all of your, in this room are probably the same game, we look at the network restrictions that come with unicast versus multicast. What we found is the immediate savings was in the data center. All it took was 4 concurrent receivers of the same piece of content, and we had a 90% savings in data center costs. So it's end to end. It's not just the network. And we had a product, and we're still there in prototype, sitting in a data center somewhere in Texas. But politics get in the way. It's not our core technology. It's not our bread and butter, whatever the hell they want to say. It's stunning. And we
which brings us to the next point, which is this is essentially an effort that we're calling the multicast to the grandma architecture, and this is kind of a grassroots bottom up. Instead of this as being one large corporation, catering to the whims of the various product groups, and hoping that the right VPs like this or don't like the other thing. This is just a grassroots movement of folks who are just deploying stuff and getting stuff out there. With the hope that we can demonstrate it works and get some kind of interesting content out there that maybe goes viral and pushes the architecture. So this is more of a bottom-up approach than a top-down approach. And so how would it look? So this is kind of the whole architecture. So we have the internet. Most of it is unicast only. Some small portion of it, we call it the M-bone, is the multicast enabled portion of it. And for all intents and purposes, that is internet 2. That is, probably 90% of the M-bone is internet 2. And the M-bone comprises maybe, somewhere between, maybe 1 to 3% of the internet. So you have a multicast source and a multicast receiver, native source, native receiver on the M-bone. That works the way it's always worked, right? We have PIM sparse mode, still works today, running over I2. Now, imagine you have an off-net receiver. And that is a receiver who is on a unicast only network. Well, we have these AMT relays that have been deployed. We've talked a lot about AMT. I'm sure, this audience, I don't need to go through what AMT is. But the idea is it goes native to the relay, and then from the relay, it gets tunneled over unicast, over UDP, via AMT to end users. And I just saw a comment, but hold on a sec there, Jake. Off-net source, so that's off receiving. Now, off-net sourcing. How do we get somebody with a camera phone who just whips out their phone and starts hitting record, and they want to stream it natively onto this infrastructure? They're stuck on a unicast only network. That's where Lisp comes in. And we actually, this was demonstrated with Dino in Singapore, where he was able to get, I believe it was on his iPhone, he was able to, from the unicast only Wi-Fi network in Singapore, inject ping traffic that was seen on multicast routers and generate state. So imagine what we're missing, the piece we're missing is camera video. That's what we want rather than ping traffic. So getting camera video, we've got all the other pieces in place. So you get camera video, streaming multicast. Lisp would get it to a TR at the border of the M-bone, which then can get it natively to native receivers, as well as off-net via AMT to off-net receivers. So should I end, Greg, shout up. Do I have questions or should I keep going?
Each other. Oh, oops, sorry, my mute was off. No standing questions, just a discussion taking place. People, All
right, cool. So what is our plan for world domination? 5 steps. First, we got to get relays. Second, gateway implementations. Third, a portal. How do you solve the search problem? How do you find the content? Next is getting the off-net sourcing to work. And then step 5. Oh, shoot, what is step 5? Yes. All right, so let's dig through them. Where are we in each of these steps? So the first AMT relay was deployed at Thomas Jefferson High School. Subsequently, George Washington University has added 2 more relays. I spoke at I2 Tech Summit Tech Exchange in December, and in several I2 institutions were interested in adding relays. my day job has prevented me from nagging them, but I will be reaching out to them, and we need more. So if you're interested in, if you're connected to I2, if you have, say, a Juniper MX router, it's 4 lines of config is all it takes. No extra hardware, no licenses, no nothing. And if there are other vendors who also make AMT relays, please speak up and join the effort, and we'd love to, use your relays as well. The relay discovery, for those who are curious, what do you do when you have more than one relay? It was really easy when there was only one relay. What we're doing right now, for now, the solution is DNS based. I think this is the Jeff Houston advice. F it, just use DNS, right? Just put it in DNS. So we have a fully, AMT relay.m2icast, multicast to internetcast.net. That maps to, and we have each of these 3 relays has an A record. So we've built resilience into the application layer. So in the case of VLC that we've implemented, VLC gets an ordered list. The receiver will get an ordered list, or the gateway will get an ordered list of all the relays. And it just picks one, and if it gets no packets, it'll pick the next one, and it just goes down the list. So we have relay resilience, we have relay redundancy. Now the next question is, what about relay optimality? And we're just going to punt and hand wave for now and say we don't need it yet, but we'll need it someday when there's a lot of relays out there and there's a lot of content out there. And I have some ideas as to how to solve this problem, but if others do have some other ideas, please reach out to me and email me. But here's a hint: it's probably, I could see using DNS to solve this problem. Gateway implementation. So the goal is yes, RFC 8777. Actually, this is one of the things that is in RFC 877, which is statically using one and going down the stack if it's not there. Though, yes, DNSSD is out there.
And the Torless question? Or was that the old one? No, it's a new Torless question.
Yeah, I'm not sure if you wanted to go through the whole thing first, so it's not urgent.
I'd prefer to go through the whole thing unless you have something that needs to be clarified or disagreed with on a specific point. But yeah, let me continue on because I'm almost done. All right, so our goal was to build, this is what I would call the last foot problem, and this is what Jake is really solving. The last foot problem is how to get it from your screen to your eyeballs, or how do you get it, from, and that is, we wanted to build a gateway implementation that's easy enough for any user to use. The short term, we settled on VLC because VLC is multicast friendly. It's multi-platform. It's open source, and Natalie Landsberg and Wayne Brasem implemented an AMT gateway for VLC and that patch, and they were able to get it upstream successfully. It is in VLC 4.0.0 today, so you can go to the website and download it, and you will get VLC, AMT capable VLC. Now, this is just a short-term solution because this is the best we could do. What we really want, and I would encourage everybody, please go check this out and try it out. In the long term, what we really need is multicast to the browser, and so Jake's doing the Lord's work. So we, this is what we really need to solve this last foot problem. All right, so the content portal. This is the most recent development. So Lauren Delwich, who is another student from Thomas Jefferson High School, she is building off of William Zhang when he first deployed the first AMT relay. He combed through all the multicast content on I2. He basically went to the looking glass routers on I2, looked at the multicast state in the actual routers, and came up with, here's a list of content out there. And she's basically building off of that, starting with that, and now populating onto a nice pretty web page that you can hopefully launch VLC from. She's made some progress. This is, I would say, I believe Lauren might be still on. But she's made a lot of progress. She just posted this maybe 2 days ago. So we're kind of actively going through this, but I encourage folks, take a look at it, see how useful it is. And if you have comments, please reach out to the team, reach out to Lauren with any content. But she is certainly looking for help. She's having some issues trying to launch an application out of a browser, which is remarkably difficult for browser security reasons. So anybody who knows and can help with this, I'll shout this out. You know, some apps can do this. Zoom can, Microsoft Teams can, WebEx can. You can launch an app from a link. We're struggling to get that working. So if anybody does have an idea as to how to make this work with VLC, please shout and raise your hand or just shout right now and tell me, and we'll reach out to you. Shout we needed. All right. All right, Torlis, since you raised your hand so enthusiastically, we will be reaching out for you for a solution there.
Oh, sorry, that was just my phone ringing in parallel while I was waiting. No, thank you. So I think, you know, it sounds very much aligned with what Jake is doing. And so I think would be good to maybe, you know, on all the sides, make it clearer if there are any differences, because I'm hoping there is one, you know, story going forward and everybody is, you know, working on his pieces. I think Jake primarily on the browser side. I was wondering specifically, and sorry if I should be aware of that, but I read everything, if the approach that, for example, Verizon presented earlier on, which I think wasn't pure AMT, but was this trick of doing multicast and then at the transport layer create a unicast stream locally through an agent on the, so that you could use an unmodified browser that only knows unicast, right? I remember that. Right. So we had the same type of workaround once. I think that there's even an open source implementation of that, right? AMT over to, I think, a TCP stream. If that's a reasonable part of a plan to total world domination on the host side.
Hey, Torlis, this is Gian. Yeah, you know, so it does sound similar. I think, you know, before we actually looked at the RAM product, I think we did look at like WebRTC that I think does like messaging. Sorry, I think there is a way that you could actually get it to work, but it actually does require some development. But with WebRTC, that you could actually take the stream and then somehow you can actually get it to play like in a web browser. But we didn't actually, instead of buying it, trying to develop it in house, we ended up just buying a product that did it. But I think there is a way that you can develop it. Yeah.
And I think there are a bunch of different ways on how to do this immediate step, like, you know, unmodified browser with this agent, and maybe saying, hey, here is the, you know, open source or best recommended agent, something like that. And I was just bringing up the point if that's interesting for the whole strategy. Obviously, native within the browser is total world dominant, but would rather know how long away that is, if there is value for it.
Torlos, are you familiar? You know that NP API? It looked like that was kind of like legacy, like that Netscape it's called. Yeah, so that was legacy, and I think it was supported by older browsers, but then they removed that support for all browsers. So then that did make it difficult. So any new browser now you can't play you in any video, which made it hard.
That's a plugin issue, right? And with the plugin issue, I think right now it's either get new native code into browsers or an agent, and that's why basically this agent part was something where I was wondering, you folks feel we should go, because you have been successfully running with some proprietary agent. I'm not sure what Jake's thoughts are. I'm not sure. See, still there?
Yeah, so my thoughts are that the core problem is that is a garden solution. So it's really about the delivery of multicast. I think that the VLC and some other approaches all would work fine if you could actually deliver the multicast, but you cannot.
I'm talking about an agent that natively receives SSM or AMT tunnel if there is no SSM, and then translates into a TCP or even HTTPS stream locally on the receiver device so that you can use the browser.
Yes, you know, it does sound almost identical, like Torlis, what you're saying with this RAM product. So like when it actually sends it encapsulated, just puts it in a UDP payload, ships it out across the tree. and then receiver gets it, he unpackages it, and then he just plays it out. So that stream, that native stream, is like an HLS stream. So now he's able to play out that lane. He just plays it out on his loopback. Sounds like the software, it can't be that difficult, but it's just an agent that does that. It does the join.
There's a standard in cable labs that defines exactly that method, only that the agent isn't sitting locally on the host, but on the home gateway.
So DVB also just published last month a standard that does the same exact thing. Yep.
Well, yeah, I just wanted to bring that up as, potential good part to consider for.
Say, WebRTC, that was mentioned. That was one of the areas we I believe when we were looking at WebRTC, there were issues with WebRTC, like it couldn't support UDP or couldn't support multicast explicitly. So that's why WebRTC was ruled out at the time.
RTC never cared for multicast. Sorry, I have to rant about this because we tried to bring it in early RTC and nobody was interested in that group, of course.
We looked at it a little bit, when we looked at it in the beginning, but I think there's some, because it does like messaging, but there is some kind of translation that you have to do to get it to work. And I think, just looking at it, when we did look at a high level, it seemed like it was possible, but I think you had to do some translation because the multicast, before that, for that stream to be read by the browser, you actually have to take that multicast and translate it to unicast. So there was a translation, and I think that the WebRTC, I think the way it works, it's kind of doing like messaging between the client and the server. So it would actually do it would have to do part of that translation, I guess, from multicast to unicast for the browser to play out unicast.
And I don't think in browsers WebRTC APIs integrate with DRM, whereas if you convert locally on the host into a TLS string, that obviously would be, easily, go into all the DRM stuff that exists.
I see.
Yeah, thank you very much.
Yep, welcome.
One of the things you did mention, I think you mentioned there was some source that took ANT into TCP. If you do have information about that, we'd love to look at that. I was not aware of that.
Do you remember, the...
Anyway, all right, so moving along. Well, just email me or if you don't recall it at the moment. All right, so often, like I said, you have a source that's on a unicast-only network and subject multicast content. We can on-net source today, but most, I think this will be the killer app, and I think this could be the killer app for multicast, which is if anybody could be walking around the street with a phone, with a smartphone, and could start streaming live something that, an arbitrarily large audience could easily watch immediately, upwards of thousands, tens of thousands, hundreds of thousands. Anybody can be a broadcaster with an arbitrarily large audience live. I think that has the potential to really be impactful, and that's kind of the killer app. So there's different approaches. There was the idea initially of a server we looked at, and then Lisp seemed to be a way to do it, and we were able to demonstrate it. What we really need is find a way to get a smartphone camera to be able to stream the video as multicast instead of unicast. Some progress has been made on this. We had a developer who was working on this, and he had made progress, but still working on it. So we're looking for folks to speak up, to jump in and help on that.
Can I suggest, in terms of requirements here, I think the requirement that the source is multicast is misguided. Multicast is the header. That's the transport. That's how it goes out. All we care about is the content getting into that multicast infrastructure, and it doesn't need to come from the phone into the multicast infrastructure. Because in most cases, you're going to need to transcode it. You're going to need to send it in multiple stream rates for various receivers, and you're going to archive that stuff. So it all has to go to a cloud storage anyway. Architecturally, I think the correct way to do this is let anyone unicast the content overlay up into the data center, wherever that transcode and storage is taking place, and then into the multicast distribution trees from there.
That's certainly one approach. You know, we got it. I think we have it, you know, with Lisp gives us the ability to do that today because, you know, it's
sure.
It's not impossible to have a camera video that spit out multicast packets. It's just getting them somewhere, and that's where Lisp comes in.
Lenny?
And yes, you know.
So yes, I mean, I agree with Shep was saying, and I also agree with you're saying. It turns out that when Lisp runs on the source, the application still thinks it's sending out multicast packets, but they are in effect being unicasted somewhere else, and they may be unicasted to that, you know, reformat or whatever that Shep was talking about. Yeah, that transcoder or whatever. So, I mean, it kind of doesn't matter if we think the bar is going to be higher to get applications to run like VLC. VLC could do multicast from the app itself, but there's no available applications that will read the camera data and send it. So I think if we create the multicast service model for the product, and receivers can join and leave, it doesn't matter how the data is sourced, right? We could even just use a browser or something, and the packets that leave the application could be unicasted, and they could be unicasted to a spot that actually then translates the destination of multicast if we are really, you know, head bent on packets the destination address must be in a 224/4 range or whatever, you know. So I think there's some flexibility there. It depends on what we think the roadblocks are going to be at that source application.
Yeah, I should say I'm not, I'm kind of agnostic as to how to solve this problem. So whether it's spitting out multicast packets natively from the source, or it's going to some thingy in the data center which takes in unicast and spits out multicast.
The other thing is if you want it to really be on a cell phone and while people are walking down the street, you have to deal with NAT traversal. And usually unicast is a better way of doing that. And that's why Lisp worked well in this test that we did, because the NAT traversal functionality for multicast packets that were encapsulated in unicast were able to pierce the NATs on outbound. We also have the problem on inbound as well, right? So
I think it's important to, even if the browser, if the source is spitting out multicast packets, that doesn't help you if you're not on if you're on a unicast only network. You need that overlay that somehow gets it there, whether it's Lisp, you know, tunneling it to the multicast network, or that it's a unicast stream to the multicast network. You know, as a plain old unicast thing. I think, you know, I'm agnostic. We just need something that works.
Yeah, agree.
And you know, if there's folks who are interested in helping with that effort, we'd love your ideas. We need more work there. So what's in terms of
sorry, Lenny, real quick, what we need, if people could find a resource, is we need somebody to write an app on iOS and Android that takes camera output and sends it on the network in any form. Okay, and if somebody wants to write that application, then we can urge them to send both unicast UDP or multicast UDP.
Yeah, and I should point out, I did a little bit of research, and I did find that there's a number of apps that do this in unicast. It's a little trickier getting it in multicast.
Isn't there VLC for Android?
Well, VLC for Android does not have sourcing capabilities, so the
on a phone.
For the record, we did this with Flip a long time ago.
From the camera on a phone. So if
I couldn't even get VLC to source any data unless it was a video file that was cached locally, and usually it pulls it from a server. It was kind of backwards. So, but send me a pointer to what you found, Lenny, because maybe we can turn that into multicast that like a head end somewhere, like Shep was saying.
Sure. Yeah, and in fact, I may have found a tool that actually does that, and it may be open source. So, yep.
Awesome.
All right, cool. So here's just references. If any of the things, if you want to take a look, I'd say start with the VLC repo here, because this it gives you a pointer to where you can download the correct images of VLC. And it also gives you usage documentation, how to actually show that it works. But this is something that everybody can download right now and start watching content on the MBO right now. And then there's, other past projects. And I encourage you also take a look at Lauren's multicast menu. We do have a Slack group. If you're interested, shoot me an email and we'll add you to the Slack group. And with that, that's everything I had. Questions for anybody else who?
For the for the VLC player, does it have to? Is it a special AMT version of the VLC player, or just a standard VLC would work?
No, it's just the latest version. It's the it's kind of, I think, beta-ish version.
Oh, I see. Just the latest. Okay. Okay.
It's 4.0.0. Is there?
Okay.
Yeah. But you get.
Okay. Got it. All right. Thanks.
Okay, that's it for me.
All right. I'm done. Anyone else?
That show. That's the end of the agenda.
Thank you very much.
All right, minutes are in Etherpad. We'll post those up. We'll split them if needed. Thanks everyone for joining and putting up with our remoteness.
Yeah, please sign the blue sheets, and you've all won an award for those of you who are still around for sticking around for 3 hours, 3.5 hours, a 2-hour meeting.
I bought pizza for everybody, so come by and get a slice.
And I've got the beer. I've got a beer for everyone.
Perfect.
All right, thanks. Yeah.
All right, thanks everyone.
Thanks everybody. Cheers.
Yeah, thanks everyone.